Do you know the pyramids in Egypt? They stopped building pyramids. I don't know if they ran out of pharaohs to build pyramids to, or they ran out of money. One day they stopped. Do you know the pyramid, the top of the tallest pyramid? Do you know what year we built something taller than that pyramid? After that pyramid was built? It was in the Paris Expo. The Eiffel Tower was the first object we ever built as a species taller than the pyramids. So just because you're doing something in one period of time doesn't mean it will continue forever. In fact, one of my great fears is that you end up taking it for granted.
The very statement makes sense, means your senses can contemplate it,
right.
That your senses have experience. If I let go of a ball and it floats up, you'll say that doesn't make sense.
Right.
Because your senses always told you that if you let go of a ball, it drops.
Right?
And in fact, the very statement, let it go, means drop it. They mean the same thing. But that can only be true on Earth with a force of gravity pointing down. In space, in free orbit, you let go, it just floats there.
Stays right there.
Stays right there. So.
Like my problems.
Stay right there.
Yeah.
Do you know that planet-wide greenhouse effect was first discovered on Venus? Venus has a really bad greenhouse effect. It's 900 degrees Fahrenheit on Venus. And I did the math. Venus saw it. You could take a 16-inch pepperoni pizza, put it on the windowsill, and it will cook in 9 seconds. Okay? That's hot.
We think of ourselves as pioneers in space.
Yeah.
But that's not really how it went down. Okay? Russia launched the first satellite, named Sputnik. Thank you. Russia launched the first mammal in space, Laika the dog. Russia launched the first human in space, Yuri Gagarin. Russia launched the first woman. Russia launched the first black person, who was a Cuban national. Remember, Cuba was with them, not us. Russia invented the rocket equation more than 100 years ago. Russia did all this, and we said, how can we do something to show? So we said, let's go to the moon. And so we went to the moon before them, and we said, we win.
And that was it.
But you have to consider that we were reactive, not proactive, to Russia's overtures.
Emerging research to suggest that the virtual particles that pop in and out of existence are connected, they're entangled, they're quantum entangled.
Awesome.
And if we think of that entanglement as with their connectivity being provided by mini wormholes,
right,
it may be that these mini wormholes is the literal fabric of space-time itself.
The red spot on Jupiter, we call it Jupiter's red spot.
Okay.
Because that's how we roll.
That thing is
Spots on the sun, sunspots. See?
Forgive me for not remembering the name of this person who uttered this, but upon realizing with the power of a bow and arrow, you could kill another human being without actually looking them in the eyes. And the conclusion was, that's the end of bravery. And so I thought about this, whoa. Any tool where you can kill at a distance, that's cowardly on some level. And the progress of military conflict has been, how far away can you kill at a distance?
Isn't it suspicious to you that a storm there could go on for 350 years without a break, and we never have storms that go on for 350 years without a break? We don't even have storms that go on for like 6 weeks without a break.
So, first of all, these storms are, when we have storms, it's in our atmosphere. So that's gas.
Yeah.
We rotate once a day. And so that rotation creates what we call a Coriolis force, which moving air that moves from one latitude to another, actually has its direction deflected because of this Coriolis force. And this is why storms rotate in one direction counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. The Coriolis force is heightened if you spin faster, okay? And so what is Jupiter? It's 100 times bigger than Earth. More than that, 1,000 times bigger than Earth. It's like 10 times across, cubed. So it's 1,000 times bigger than Earth. It's mostly gas. And it rotates once in about 10 hours. You want to talk about ferocious Coriolis forces? We have storms that last weeks here. Hurricanes that pick up and they get weeks. on this little speck we call Earth that has this much atmosphere on it. Go to a planet that rotates twice as fast, is 10 times as wide, 1,000 times the volume, and is mostly gas, and you're complaining that it lasted 300 years?
You are really good.
I can't speak for cat owners, but those who own dogs, you know that every time you come back from wherever you went, the dog is happy and it's jumpy and it wants to lick you in the face. Even if you just went to get mail from the mailbox, they delight in your return. If you want to take them out for a car ride, they are the first in the car. They jump in. They don't care where it's going, but they're going somewhere.
Yeah.
They're some of the most joyous creatures that live among us. And no, I'm not a dog psychologist, but let me offer a plausible account of this. Okay. Dogs don't live as long as we do. An old dog is like 14, and then they die. We live to 90 if we're, eat well and wear a seatbelt. You divide the two, you get basically a factor of 7. Okay? Yeah. So this is where the 7 dog years formula comes from.
Gotcha.
Okay? So if a dog is 3, they're 21 in dog years. This is what we say. How authentic is that, you can ask? It's a convenience, but is there any deeper meaning to it? And I think there is.
Okay.
It means every single day a dog lives is equivalent to a week of your life.
Oh wow,
that's a 7-to-1 ratio.
Poor handsome.
So if they only get 1 day for every week you're alive, they make every day count. Now, of course, they're not doing the math.
I gotta take my dog for a walk.
If one was able to stop time, is it true that you wouldn't be able to see anything because the photons would freeze too? Can we make an exception to that?
I don't know if I have a good answer for that. No. Because to the photon, there is no time. You might have heard that the faster you go, the slower time ticks. This is relativity. And in the limit, at the speed of light, time stops. Yeah. Photons, which exist at the speed of light, when they are emitted at wherever they came from, my PhD thesis was on the center of the galaxy, which is 30,000 light years away. And when I captured those photons, for me watching them, they took 30,000 years. But if you're the photon, the instant you left the center of the galaxy, you hit my detector.
You're right there.
In the same instant.
Yeah.
So if there's 0 time, I don't know what effect that would have on the photons.
Right.
Because they don't ever have time.
Yeah, they're outside of time.
In a way, they're outside of time.
Black holes are not giant sucking machines.
Right.
They just have a gravitational field.
Gotcha.
If you get really, really close, kiss your ass goodbye.
Right.
If you're not, you'll just maintain an orbit around it.
Like we do the sun.
Like we do the sun. Exactly as we do the sun.
Right. We don't crash into the sun. We're not getting sucked into the sun.
Right. And so if you step back, it looks like all the planets are spiraling around, which they are.
Right.
But they're not getting sucked into the sun. Right. All right. So the toilet bowl effect.
That's swirl.
These are called spiral arms, and our understanding of them came of age while I was in graduate school. Because how do you maintain that? And because the inner parts of the galaxy actually will complete an orbit faster than the outer parts. So you get this stretching of these coherent cloud formations that, because the galaxy rotates, as we say, differentially, which means the inner parts rotate faster than the outer parts, it will drag it into this spiral shape.
Right.
And one of our big challenges was, how does it maintain the grand design 2-arm spiral without over time just winding up on itself?
Right.
Okay, so that's where it got complicated, and we had to worry about what's called spiral density waves. It's not really a physical gaseous structure. The gas is everywhere. There's a density wave that's moving across the clouds, triggering star formation.
Wow.
So wherever this density wave is, there's star formation in that shape. So it's more complicated than it looks, but all I'm saying is everything is just simply orbiting the center of the galaxy.
Right.
And it's not like a toilet bowl that's ultimately going to go down the tube.
Right.
So think about this. Just think about this. If there were ever a state secret that the government wanted to keep, it would be the behavior of President Clinton's genitals, okay? But that got out. That got out. And only 3 people knew this. 3, all right? You're going to hoax a moon landing by telling 10,000 scientists and engineers to keep it secret for 40 years? That's not how humans behave. I forgot who the author was of this quote. He said, the only way you can keep a secret between 2 people is if one of them is dead.
But that's not true militarily. I mean, we've kept big secrets for long periods of time.
You can keep, sure, but really delectable secrets don't last. I can keep a secret that there's a bunker that I'm going to run to, sure. Right. But to keep a secret that like aliens landed and are DNA experimenting on us, that would get out. That's what people do. Stuff lesser stuff than that gets out. Beyond a certain number of people, the conduct of human beings, if the secret is really juicy and really, really tantalizing, I think there's 0% chance that that's like.
Have you ever seen the video of the astronauts on trampolines?
No, I haven't.
I never thought in my life that I would be in the position to have a real astrophysicist watch a ridiculous video. The conspiracy is that they are either on trampolines or they're on some sort of a wire harness because of the way they're moving. Now watch this.
We were going to do a bunch of exercise that we had made up as the Lunar Olympics. Show you what a guy could do.
Doesn't that look like a guy just got yanked up in the air? You think it's weird to look at that video and think it looks odd?
It'd be weird if you otherwise knew
what it looked
that
like.
A 33-story rocket filled with fuel, launched from Cape Canaveral, took several orbits around Earth, went to the moon, took pictures from the front side of the moon, the back side of the moon, images from the surface of the moon. A week later, it comes back. An aircraft carrier goes into the Pacific to pick up a capsule out of the ocean. Mm-hmm. People get out of the capsule, get on the spacecraft, the president meets them, and then someone shows you a video and says, well, maybe all of that didn't, that was all fake.
Well, the idea is not even that it all didn't happen. The idea proposed in the Kubrick documentary was that they made a lot of extra footage, and that a lot of what you see is faked footage where they were worried that they weren't going to be able to do it, so they decided to fake it, and some to see if they could fake it.
That's a whole other thing. That says we did go, but they needed a movie director to help out the view.
So you see something like that with your knowledge, that doesn't look...
it's completely straight.
It looks totally normal.
Well, yeah, it depends on how quickly they return to the ground. Other things, you want to look at how far away the horizon is. I want to see if dust was kicked up, and does the dust fall at the slower rate that the astronaut falls? I don't see the dust in this, so I'd say this is not enough information. You can't put wires on dust. Every time they step, the dust came up. So you'd look at all of these cues, and there's so many cues that would happen naturally, if it actually happened, that you'd have to think up and get perfectly to fool an expert who knows what they're looking at.
If they know what it's like.
That's why it would have been easier to simply go to the moon than to fake all of that. That's my point.
This is the one where it looks like the guy gets yanked up by a wire. Have you ever seen this? Check this out.
Oh.
Guy's on the ground.
How much do you weigh right now?
190.
190. So now let's add a 200-pound pack on you. You now weigh 420 pounds. You're sluggish here on Earth.
Right.
I put you on the moon. Your muscles that normally are accustomed to 190 pounds now are carrying 1/6 of 420 pounds, which is 70 pounds.
Right.
Imagine how awesome you would be, how awesome you would look.
If you weighed 70 pounds.
If you have this musculature and you weighed 70 pounds, you'd be Superman.
You literally could spring up as if you were pulled by a cord.
You can spring better because the cord has to make you feel like you're 70 pounds, but now you are 70 pounds, so you just do it. So here, I got another one. Consider that Muslims, part of the rituals of being a Muslim is you're cleaning your hands and your feet. And your ears and your nose, and there's a cleansing daily. But just think about this. Back then, nobody's showering every day. But some funky times. Okay, there's some people don't shower every day today, but you could. And United States, we probably take more showers than anybody else in the world from the research I've done on that. But point is, if a disease comes through and it comes from contact or some other thing because you're dirty, you get sick and the Muslims don't.
Oh, so they seem powerful.
Oh my gosh. And you're Christian and they're Muslims. You're saying they put a hex on me. These heathens. Okay.
Wow.
This is how this can happen. I got another one. You ready? So we would later learn that many of the plagues were from a flea. Okay. So now watch. So the flea would get infected and would bite you and you'd get the plague. Okay. Okay. The plagues have killed more people than more than wars. Okay.
Oh, wow.
All right. So now watch what happens. Where did the fleas come from? We would later learn they came from rats and mice. Okay, that were infected with the plague. If you owned a cat, you didn't have mice.
So you didn't get the plague.
You didn't get the plague. No, wait a minute. Who owned cats? Well, there are many women that owned cats.
So women didn't get the plague, and they were therefore sorcerers.
They were witches.
Damn.
And you still associate a cat with a witch.
Yeah.
To this day. This is what happens when you live in a pre-scientific era.
Wow.
The blame game begins.
This is about the size of the moon.
20 inch in diameter, this is 5 inches. So who knew the moon was that large? This is Mars.
Sure, that could be Mars, yeah.
It could be Mars 10 inches?
Oh, yeah, that's
10
right.
inches, is
That's
that
about
right?
right, sure.
We're going to do an experiment of how far, to this scale, if we're according to this scale, how far away the moon might be.
Oh, sure, okay, so
let's see.
here, I'll give you the moon. Here, come here. Stand right here. Okay, you now have the moon. Put it where the moon is relative to Earth is the size.
Where do you think it is?
Right there.
Right about there? That's about the right distance?
Given that this is 20 inches and this is 5, you think the moon is...
Right about there.
Something like that.
Okay. That is way off, okay? Okay. Just start backing up.
Yeah, and
Keep going. Keep going.
Turn around while you're going.
Keep going. That's about right. Yeah. That's about the Earth-Moon distance. Yeah. You know why? You've been lied to by textbooks that have to squeeze them both into the same page.
And then the positioning of Mars.
Oh, yeah, okay. So, well, you know it's got to be farther than the moon. I'm going to really save you this effort here. It'll be like a mile and a half away, which is farther away than Town Lake. Space is empty. You know the people who say this is a universe made for us? No, it's not. Most of the universe is completely empty, and you'd be dead within seconds if put there. If the Earth were actually this size, the International Space Station would be orbiting about a half an inch above the surface. And that dude who jumped out of a perfectly good balloon, he would have been about 2 millimeters above the surface of this globe. That's his edge of space jump.
Oh, time for area codes. All right. Well, they already had a set of digits that were reserved for certain tasks. So 411, if you type 411, that was reserved for information. Mm-hmm. You dial 411 and you'd get a human telephone book, basically. Right. What is the number of Johnny Jones, whatever, or Mary Smith at this address? They'd look it up, and sometimes they'll dial it for you, or they would just tell it to you and you'd write it down.
Wow.
Right. Okay. Yeah, this is like forever ago. All right. So 611 would be if there was something wrong with your phone and you needed repairs. Okay. So they say, we'll be by tomorrow to look at the phone line, whatever. All right. So they had a few of these that all had a one in the middle. Okay. However, those were established after area codes were established. Okay. Mm. Now, they knew we're not going to have a phone number beginning with a 1, nor a phone number beginning with a 0. So the highest population city, New York, they wanted that to be where the area code can be dialed the quickest, because the most number of people would be dialing it.
That's right.
And you don't want to burden so many people with waiting around for the dial to finish dialing.
That's right, because you're going with the finger thing.
So with the finger thing.
Can't have 211, so you got to have 212.
212 is the shortest time dialed area code on a dial.
Yo, that's cool.
Okay, so now, what city has the next highest population?
Probably Los Angeles.
Los Angeles. What is the area code of Los Angeles?
315.
213.
213.
Low. That's why you have this. Okay. What's the next most populous city?
Probably Chicago.
Chicago. What's the area code of Chicago?
I don't know it, but I'm sure it's 214.
No.
Oh.
I can go lower than that. 312.
Oh, 312. That's right. Because you're staying in the little, you're staying in the thing.
Why is the past different from the future? Why is there an arrow of time? Because the fundamental laws of physics have no arrow of time in them. The answer is entropy. And the second law of thermodynamics, the universe used to be more organized, lower in entropy. The whole history of the universe is just entropy increasing, disorder and chaos developing all around.
We're all going to die. That's the...
It's not your fault necessarily, but you're contributing to the disorder and chaos all around us. And that started about 14 billion years ago near the Big Bang. At the moment of the beginning of the universe, our universe was exquisitely orderly. Doesn't necessarily look that way, but you run through the numbers and it's true. Why? Why is that true? Why was the early universe so orderly? And so I've long wondered about this, and I wrote a paper years ago now with a woman who was a graduate student of mine at the time, Jennifer Chen, where we proposed that the Big Bang was not the beginning of our universe. Other people proposed that in different contexts, but we made the case that you don't need a fine-tuned, special, organized, low-entropy beginning of the universe. The universe can be eternal, it can last forever, but what happens is it empties out, just like our universe is doing. A universe can be completely empty, the future of ours will be, but it still won't be perfectly quiet. There are still quantum fluctuations that can lead to whole new universes coming into existence. And as that happens, they all start in low entropy conditions, and the entropy grows and gives that little part of the universe an arrow of time. And the fun part is, the far, far past, the same thing happens, but in the other direction. So there's sort of a symmetric shape to the universe, where the future is a story of more and more universes being created and the arrow of time pointing in that direction. The past is a story of more and more universes being created with people in them who think that we are in their past.
So, Sean, what you're saying is there's some symmetric point among these universes and these time continua where we're in one direction, where entropy increases. But in principle, there's a whole other realm where entropy decreases.
From our point of view, from the people living in it, they will always see entropy increasing because we always define the past as the direction in which entropy was lower. So it's a big U shape that is perfectly symmetrical.
I get it now. So we're in their past because they're looking at us and seeing a decreasing entropy, which is indicative of traveling backwards because we're moving towards a more ordered universe. But we cannot be moving towards a more ordered universe if we're moving into the future because we are always moving towards entropy. So if you are observing that, then you are I am in your past. So, because you're looking at me going towards order.
Chuck gets it. We're done.
Yeah, man.
The lie is, what is real is the electron field. And little vibrations in those electron fields show up in our detectors as particles. So it's not that we haven't measured the size of the electron, it's that there is no such thing as the size of the electron. The electron is a vibration in a field. It can have different vibrational wavelengths.
And it shows up as the particle.
Yes.
So you cannot measure the electron in its wave state to be a particle, because the act of measuring it turns it into the particle.
The way that we usually measure things, you say, where is it? And you get a little track in your particle detector because you keep asking where it is, and you always get a definite answer to the question, where is it? But when you're not asking that question, it's spread out all over the place.
Okay, is that the lie or the truth?
That's only the lie. I haven't even gotten to the truth yet.
Okay, now give me the truth.
You realized in the 1920s that you thought the electron was a little particle. In fact, you should describe it in quantum mechanics by a wave function. If you ever took chemistry, if you ever saw those pictures of the orbitals of electrons, etc., that's the wave function of the electron.
Mm-hmm.
Soon thereafter, you realize, no, actually, you should be doing field theory, quantum field theory. And so there's a field that the electron is a vibration in. And you're asking what really exists. Well, there's a wave function of that field. So there's like fieldiness on top of fieldiness. And finally, you say that, okay, what if you have like different fields, different particles? Do they each have a wave function? No. There's one wave function for the whole kit and caboodle of them, the wave function of the universe. That's what's real, the wave function of the universe.
So everything we know about the universe, what we're made of, galaxies, stars, planets, that's all right here. So according to this chart, we are 96% stupid in the universe. We got the Big Bang. That's been going for a while. Now, not everybody's happy with the Big Bang. You found this billboard. So apparently, God isn't happy with the Big Bang. I would have thought he'd be totally cool with it, but apparently not. I found this bumper sticker in New Mexico. The Big Bang Theory. God spoke, bang, it happens. This one is okay with the Big Bang, but that God did the Big Bang. So people are still trying to wrestle with this. Here's what we know. This is the entire universe in one slide. Quantum fluctuations, birth, an entire explosion, rapid expansion, we call it inflation. There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first stars. We call it the dark ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later, and that telescope, we can't see the whole name, it's called WMAP, Wilkinson Microwave Anisotropy Probe. They clearly didn't want anyone to pronounce that or remember it. I would just call it the Big Bang Machine. That made this measurement. And so it's a pretty coherent picture that we have of the origin of the universe. And here's that map that the space probe shown. And so this is a record of the earliest moments of the universe. And it tells us what the universe was up to. And data agree, we're all pretty happy with this, and we're kind of moving on. The Big Bang, by the way, could fit into a larger story. For example, the multiverse. Big Bang is probably not the whole story. It's probably a piece of a bigger story. So maybe there are multiple Big Bangs. This would give us the multiverse. We don't have data for this, but we have good theoretical and philosophical reasons to think that a multiverse exists.
How long do you think the human race will actually survive?
Well, so you can look at what is the average life expectancy mammal species.
Exactly.
And last I checked, it was around 2 million years, something like that.
Oh,
and so we've been around.
Have a long way to go.
We have a long way to go. We've been around, a couple 100,000 years in our current anatomical form, Cro-Magnon form.
Right.
And so that means we have a long way to go. So if we follow the reasoning by Steven Pinker in his book, The Better Angels of Our Nature, he studied the likelihood of you dying before maturity or dying before adulthood or just dying at the hands of another human from early days of tribal warfare to modern days of state-sanctioned global warfare. And what he found is that the likelihood of you dying in that way has been dropping ever since. So tribal warfare, you would kill maybe a third or half of the other tribe or the entire tribe, and then you win and you get their land. That doesn't happen today.
True.
The state surrenders before that happens.
True.
Saving the lives of the rest of the population. If you look at, I did this just recently. If you look at what countries had the greatest percent of their population die in the Second World War, was it Belarus? One of them is very high. It's like a third. All right. I forgot the exact numbers, but they're high. But they're not a half. And you keep going down and you get to even combat Germany, even ones that were heavily bombed. Germany, Japan, a fraction of the total population. That is not how it used to end in tribal warfare. So now consider that even so, during the Second World War, between 1939 and 1945, 1,000 humans were killed by other humans per hour for every hour from 1939 to 1945.
Wow.
Is that going on today? No.
No.
Oh,
we're really slipping.
No, stop.
It's 1900. There's the fear of the great manure catastrophe. In Manhattan, which is not a large place, and you access it by bridges and tunnels, it's an island, there were horses, and horses do what they do. You feed them, they poop. The poop goes in the street. The horse, you don't take it to the horse bathroom. It's in the street. And the people's whole job was to clean up the manure. Now what do you do with it? You bring it to another place and it makes a pile. Then somebody else comes in with multiple horse-drawn carriages to haul the manure out of the island, okay? But those horses that are hauling the manure, they are pooping. Okay, so if you run the arithmetic on this, people imagine the manure catastrophe. And it attracted flies. There were no indoor supermarkets back then, at least in the inner cities. Most of
of food was sold by street carts. Your fish, your fruit, all of this was street carts. So the flies were everywhere. And so there was a lot of visioneering discussion about what to do about the horse poop or the flies. So they said, let's put something in the feed so that when it comes out as poop, the flies will not be attracted to it. Because that was one of the health issues. How do you get rid of the flies if you're not going to get rid of the poop? Then another one was, what can we feed the horse to reduce the amount of poop that comes out the other side? The actual solution was the car. People say the sun is yellow. No, it's not. It's white. Right? If the sun were yellow, just think this through. If the sun were yellow, then in broad daylight, snow would be yellow. But generally it's not, all right? When the sun sets, its light is heavily attenuated by dust in the atmosphere, and in other places it could be pollution or pollen, but these particles in the air scatter blue light out of the sun into the rest of the sky, turning the sky blue. And the more blue light it takes out, the more yellow-red the sun looks.
Right.
And that's why right on the horizon, the sun is its deepest yellow-red it will ever be. And people say, oh, there's our yellow star. No, the sun is white, okay? Ask any photographer, by the way. In fact, to a photographer, the sun is blue.
The reason why the moon theory is so juicy for people is because there's so much of this stuff that you could point to.
Well, take, for example, the assertion that the photos from the lunar surface, since the moon has no atmosphere, then a daytime picture, if you're there in the daytime of the moon, you see a full night sky of stars, even with the sun in the sky as well. You don't see stars in the daytime on Earth, not because they're not there, but because the atmosphere is aglow with scattered light from the sun. If you take away the atmosphere, the sun will still be there, but the sky goes dark. That's what the folks get when they go to the edge of the atmosphere, and they're calling that the edge of space. But when you get to the edge of the atmosphere is no longer between you and the rest of the universe, and the stars reveal themselves just as they would at night. So everyone knew this. So you see these photos from the moon, and there's Neil and Buzz and the lander, and there are no stars in the sky. It's just dark. And they'll say, see, it's fake. And these are people who've never taken photography. All right? If you are exposed for the bright reflective light of the astronauts in the lunar surface, that camera exposure, even in the Hasselblads that they carried to the moon and used, is too short to take in the dim light from the stars of the night sky. If you turn the camera to the sky, a much longer exposure with sensitive film, you'll get the stars, but then you overexpose the stuff in the foreground. Photography 101 answers that question, but there are huge websites given unto this. And so what that told me was that people simply wanted to believe that it was a hoax.
You know, we have an idea in our head of what it looks like when a flag waves. Well, that's obviously the wind moving that flag. But there's wind here. There's nothing. There's zero atmosphere. Now, when someone would run by a flag in zero atmosphere, does it create any wind? Is there anything?
Nothing.
Apollo 15 is the one. It's really fascinating because they stick it into the ground and then the dude hops by it, and when he hops by it, it wiggles in the breeze. Like there you can see clearly that the shaft
he had
is
just
over the top
stuck it in the ground.
Yeah, exactly. No, I'm saying the shaft is in it and it's in place and it's still sort of reacting to the environment.
Sure.
Right? And when he hops in front of it, the flag follows him like it goes in the breeze. See that?
It looks like a breeze blew it.
Yeah. So you think
either,
it's possible that that's fake?
Yeah, so either all of this got faked, or there's something that didn't make it into this photo.
Right.
And that's all. It's not.
It could have been like as he jumped, maybe a piece of dust.
A piece of something.
Kicked up and hit it.
Precisely. So I can't lose sleep over that.
Because light does not travel at an infinitely fast speed. It travels 186,000 miles per second. That's fast, but it's not infinite. It's so not infinite that you would be frustrated having a phone conversation with someone on the moon because the delay is 3 seconds. You would speak, and by the time they heard you reply to them, 3 seconds would have passed. It would not make a good phone conversation. That's how long it takes the light just to get to the moon. It takes 8 minutes, 20 seconds to get to the sun. It takes 100,000 years to cross the galaxy. It takes 1 billion years to get to the distant galaxies. 13.7 billion years to cross the known universe. It takes time. All right, put a pin in that fact. Another fact. The universe had a birthday 13.7 billion years ago. So imagine a universe that is infinitely large. Now, put yourself in the middle, and I tell you, this universe was born 13.7 billion years ago. So, let's go out to the circle, to the sphere around us, go to the spot that's 13.7 billion light years away. In other words, go to the spot where light from objects has taken 13.7 billion years to reach you. You're going to be watching that object being born because its birth light is just now reaching you.
We discovered plutonium in 1930. It is weaponized, turned into a bomb, and deployed 15 years later. That is the pace of what's going on at the time. The two bombs was a uranium bomb and a plutonium bomb. We knew uranium would work. We were not sure about plutonium. It was a new boy on the block. And so that's what was tested at, as famously now portrayed in the film Oppenheimer. They tested the plutonium bomb, not the uranium bomb. That's the one that then was dropped on Nagasaki. Point is, between 1930 and 1960, we cracked the atom, weaponized the atom, break the sound barrier, go into space. Oh my gosh, is there anything about 1960 that would be recognizable to anyone from 1930? I think not. 1989, if you had a fax machine, you were badass. 1989 was the release date of Back to the Future Part 2, which took place in the year 2015. So you get to see how they imagine it. If you remember the movie, our lead character, Marty, irritates his bosses and he gets fired. Well, he's living in a home of the future. And any home in 1989 has one fax machine. That home has 4 fax machines because that's the home of the future.
That's my favorite request on stage. Can you give us a prediction for 2050?
I'll do it. I'll still do it.
I can barely give a prediction for 2030.
I'm going to make 3 predictions. 1, we will have designer drugs. They'll analyze your genome, find drugs that will have no side effects for you. Why do we have to be a statistic in the reported side effects? You know, I'm not very side effect prone, so I generally ignore that, but many people are. So figure that out, medical community, so that there are no side effects. Have the medicine do only what it's supposed to do. Don't make it make you throw up or give you diarrhea or depressive thoughts or rashes. Fix that. Okay, that's 1. 2, I think in the not too distant future, all cars on the road will be self-driving electric. And you say, no, that can't be. No, but because we went from horses to cars in 10 years. I'm just talking about going from cars to another kind of car. That can surely be less time than going from horses to cars. Self-driving, but you know, you start that, only self-driving cars in the HOV lane. Then these cars know where all the other cars are. If you want to change lanes, it tells the other car, I'm changing lanes now. They part, it changes lanes. And they can even text and drive at the same time with no loss of their acuity on the road because they're freaking electric computers. And they can drive 120 miles an hour with 2 cars distance between them because there's not going to be something they don't anticipate. And so once you see that, cutting down your travel time, I think it's going to go quickly. And but you're a car enthusiast. What do? I'd like a classic car. There'll be car parks for you to drive them. Is that any different from people who like riding horses and you go to the stables and ride horses? It's a quaint memory of a bucolic past. So you've got your Ferrari, whatever. You park it at the car park. You'll take an electric car to get there, and you can do your thing as people who ride horses. So I see that happening. Last thing, I'd like to see space. People ask, where should we go next in space? All of space. Why does it have to be a next destination? When we built the interstate system, which to the tune of $100 billion, by the way, about the same as going to the moon, what drove that? Well, war drove that. What's the other name for the interstate system? The Eisenhower Internet System. He went to Europe in the Second World War, saw the Autobahn survive under rain and snow, and tanks could roll over without it falling off the side of the road. He says, I want that in my country as a defense project. And so the initial monies for that all came from the defense, were informed by our posture as a country that didn't want to get invaded and wanted to keep our military ready and you may know, the interstate system doesn't go over mountains, it goes through them. And after every distance, there's a certain stretch that is straight so that you can land an airplane on it if you have to. It is to military specs. That's how that money got dislodged. So I'm saying when you build the interstate, you don't build, let's just go from New York to LA. No, give people choices. So you send the interstate everywhere, let people's creativity take them to wherever they want to start whatever businesses they want or have whatever free life they want to lead in a country that we still think is free. And so when I think of space, I think of not a rocket to go here or there, get a warehouse of sort of strap-on boosters, and I say, I want to do science on the backside of this comet that's coming through. We need these 3 boosters and this rocket, and we'll schedule the launch in 3 months. Think about that. Then the entire solar system becomes our backyard. And it's not this other place. It is we'll have a relationship with it. And yeah, let's mine some asteroids. We have wars on Earth over the limited access to resources that are plentiful in the universe, in our own backyard. The future of space is one where an entire category of warfare will be rendered obsolete because access to resources will be unlimited. Category of war would be gone forever. If the entire solar system had lanes that you would take and you decided where you wanted to go, and it wasn't a single national destination.
Most Pluto lovers I've met do not know the following 3 facts. 1, our moon has 5 times the mass of Pluto. 2, more than half of Pluto's volume is made of ice. So that if Pluto were where Earth is right now, heat from the sun would evaporate that ice and it would grow a tail, which is no kind of behavior for a planet. 3rd, Pluto has an orbit that is so elongated that it crosses the orbit of another planet. Excuse me, no. So we finally set up a set of rules and regulations such that Pluto is kicked out of the Planet Club. It's still a dwarf planet, but I think it's happier there. It's one of the biggest dwarf planets.
You know what an egg is?
A cell.
No, I was going to be more metaphorical.
Oh, okay. What's an egg? What's an egg?
This is not a biology class here.
I'm sorry.
Okay, you know what an egg? An egg is a spacesuit for the unborn organism so it can survive in an environment that would otherwise kill it.
Yeah, it is.
Until it can survive, then it no longer needs the spacesuit.
That's true.
Think about that.
I've never thought about it that way.
Yeah.
That's cool. No?
Right? So the chicken is inside the egg because the outer environment can't live in that environment. So it stays in there until it's ready. Then it pops out and it can
lead the ship.
Lead the ship.
But I was born after the discovery that the heavy elements that populate the universe, and including life on Earth, including us, derive from stars that manufactured them in the crucibles that are their cores, and then exploded, scatter that enrichment across the galaxy to enable nascent star systems to have the right ingredients to make planets, and on some planets make...
I don't know. People.
Yeah, people. If lightsabers are beams of light, then since beams of light can pass through each other, just see what flashlights do, then you couldn't have a saber fight with the blades bouncing off each other. And I was perfectly happy putting that out there, but no, Brian Cox has to ruin my perfect tweet.
So Brian, what was your rebuttal?
With some particle physics facts. Okay, Brian.
Well, no, it's not particle. It's nature facts.
Okay.
I'd worked on what we call gamma scattering, which is photons, particles of light scattering off each other. So at very high energies, then there is a reasonable probability that two particles of light, 2 photons, will bounce off each other.
Okay, when going to a different planet, what aspect of traveling will be most important?
Great question, and there's a lot of thinking about this. They worry about food. Not only is there enough food, but will you like the food? If you get bored with the food, will that affect your morale? And then you're less effective doing other tasks. Do you need comfort food? Do you want exotic food, international food? The water supply. Is there enough water? Do you recycle the water? If you recycle the water, that means it collects all of your urine, filters it, and then you drink it back. Is that too freaky for you to do? Other things, the time in a close quarters with only 1 or 2 or 3 other people, months and months, and in some cases years. Can we remain emotionally stable over those times? There's the fact that if you fly without creating artificial gravity, that you are weightless the whole time. Are you perpetually motion sick, or do you get used to it? And if you get used to it, are there any other factors on the body? We already know some of the answers to that. You begin to lose bone density. You have the bones of a frail old woman. All of these factors have to come together, which is why you can't just send any old person into space.
Was Galileo treated as a kind of a devil, in a sense?
The simple story is he makes these discoveries. They conflict with the teachings of the Catholic Church. They put him on trial. They find him guilty of saying that Earth goes around the sun and not vice versa. And then they put him under house arrest. What they don't tell you, or they would tell you if you read a longer biography about him, is that he actually made fun of the Pope, public fun of the Pope. He wrote a book in Italian, not in Latin, which is the academic language of the day, in Italian, which means the local people can read it. And in it, he invents a conversation between a simpleton and someone who was wise of the ways of the universe. And all, if you track the statements of the simpleton, they're all statements that have come by official decree from the Catholic Church. So he's really a pompous a-hole, basically. There are more water molecules in this cup of water than there are cups of water in all the world's ocean. That's how small molecules are. So what that means is if I take this and toss it out, there's enough molecules in what I toss to enter every other possible cup of water anyone draws from the world's water supply. There's enough to scatter to every possible cup of water in the world. So if I drink this, it comes back out of my body in some way or another, any one of a half dozen ways. That re-enters the environment, goes to clouds, it goes to the streams, goes to the oceans, and given enough time, it mixes completely. So, Socrates drank a glass of water. It is a certainty, it's essentially a certainty, that some molecules that passed through his kidney were in that glass that you just drank. And it's not only that, by the same reasoning, there are more molecules of air in every breath you draw than there are breaths of air in all the Earth's atmosphere. So by the same calculation, every breath you take, some of those molecules pass through the lungs of whatever is your favorite historical character, Jesus. You want to think of us as separate and distinct from one another or not connected to the world, but we are. And for me, what I think of as fascinating ways. We have a quantum entanglement gap between the United States and China. They've been quantum entangling more than we have, and they have the distance record for it.
Oh, I understand.
Like from orbit to Earth's surface.
Right,
sort of thing.
Right.
They found a way to isolate the particles so that they don't get messed with. I don't think we command dimensions.
Yeah, right.
We are prisoners within them. Take time, for example. We are a prisoner of the present.
Right.
Forever transitioning between our inaccessible past and our unknowable future. We don't wield this dimension, we live it. I want that territory, not this other one. In fact, I want it all. That kind of attitude breeds violence. It breeds war, intragalactic war. So it may be that the very kind of civilization that could peacefully colonize a galaxy is not the kind of civilization that would colonize the galaxy at all.
Oof, that's heavy.
I'm waiting for someone to convince me that we don't live in a simulation.
I've heard you say it.
The arguments put forth have been quite convincing to me. And most of the best arguments are traceable to a guy named Nick Bostrom, a philosopher at the University of Oxford.
Okay.
Here's the argument. Ready?
Go ahead.
Our computing power is growing rapidly.
Right.
We create simulations of worlds. We have video games with characters that are inside the video game.
Right.
Imagine a day where you can simulate a world so perfectly with life forms, humans, so well that you can recreate every single neurosynaptic thought you could have, but now you're in the simulation on the computer.
So,
including the perception of free will.
Well, there you have it. Because so now you would have enough computing power to imbue the sims inside of the program with all of the human traits that we possess now.
Correct. Not only our human traits, but the world.
But the world.
The world itself.
Right.
And you don't have to have all the world existing there at all times.
Right.
That might be an unrealistic amount of computing power.
Right.
You just need
enough of the world that they see around them.
Right. So you want to start digging, and
that's so funny.
And I haven't put the Earth there. There's a flag that goes up in the programmer, and they say, need more Earth. So they put Earth beneath you while you can keep digging.
It's like the Truman Show.
Yeah, well, for example.
Right.
Okay.
Cool.
Or doesn't Minecraft, you can build
Or
stuff?
Minecraft.
Right.
Oh, that is Minecraft.
Right. Okay.
God, that guy's a brilliant genius. Okay.
So and we went to the moon. It's okay. Let's make sure the moon is there.
Right.
Okay.
Maybe that's why we can't travel faster than the speed of light. Because if we could, we'd be able to get to another galaxy
before they could program
that galaxy. So much fun.
So the programmer put in that limit.
Put in the limit
because that's as fast as they can get.
We can't program fast enough. So we put in a limiter. The speed of light is a limiter so that you can't get to the next thing before we build it.
All right, so let me finish. That's good.
Go ahead.
That's good, Chuck.
All right.
So let me finish this. So now that world evolves and they develop computing power.
Right.
And they say, we want to play video games.
So now we're going to make a world.
So then they make a world and they have sufficient computing power that they invent to create a whole universe within their computers.
Okay.
And then they make a world. And then they make a world all the way on down.
Right.
It could be hundreds, thousands, billions, infinite.
All right. So far, this sounds like it still works.
That's fine. So now close your eyes, throw a dart. Which of these universes are you going to land in? The first one that's real or the gazillion that are not?
Well, yeah.
Statistically. Okay.
Am I drinking when we're playing this darts game? Because
then you missed
everything. No.
So
yeah,
there's something called Bayesian statistics where you're allowed to introduce information that you already have available to you, even if you didn't measure it to be true. So we establish the likelihood that one day we'll have the power to do this.
Right.
And then that factors into these statistics.
Okay.
So there's 1 in a zillion, you're the real universe, and 999 zillion to 1 that
you're a simulation.
That convinced me. And I don't want to be convinced. I didn't like it. And I was just begging for somebody to give me an argument that was cogent enough to undermine that entire reasoning. And I just came across one.
Who? Okay.
It's a good friend of mine, Rich Gott.
All right.
He was a colleague of mine back when I was at Princeton.
All right.
Deep thinker, likes calculating the ends of things.
Nice.
With Bayesian statistics. He's heavily quoted in this book, The Doomsday Calculation. And William Poundstone is a smart guy unto himself. And I am now convinced.
Now you're convinced.
Are you ready?
Okay, go ahead.
What do all these So here is what convinced me we're not in a simulation.
Okay.
Are you seated?
All right. I'm seated.
Are you hold on.
I'm going to hold.
Okay. All right. What do all those simulated universes have in common?
They're simulations.
They have the power to simulate themselves.
That's what I'm saying. They're simulations.
No, they have the power to simulate themselves.
Right. Oh, okay. Yes.
That's what they all have in common.
Make a simulation.
They have that power.
Right, exactly.
To simulate themselves exactly. Do we have that power now?
No, we don't.
No, we don't.
Which means that we can't send it in, we can't send ourselves into the future as a simulation.
Because we don't have that power yet.
So we can't continue the chain.
Wait, so either we are the real one,
right,
or we're the one in the chain that's still evolving to try to then make a simulation within their own world.
Right.
So the odds of us being a simulation goes from a gazillion to 1. I mean, to the likelihood of
right.
Gazillion, all right.
It flips.
50-50.
Wow.
And I'm good with that. That changes my life completely.
Yeah.
Okay? And no longer are your kids going to say, Dad, it doesn't matter. We're in a simulation anyway. No, you got an argument. Do you have a rebuttal?
Exactly.
Now, a quick one.
I have to do my homework.
I go. You ready?
Go ahead.
Maybe these simulators have a side activity where they like reminiscing about days before you could simulate. That would be us.
So now we're Donkey Kong.
Donkey Kong. We're Pong.
We're classic. Yeah, classic gameplay.
So maybe we're just entertainment, like a historical exercise.
Right.
That's possible in principle. However, let's look at our own conduct with that regard.
Okay.
All right, think of a movie as a simulation, just for the sake of this conversation, which it kind of is. Ask yourself, how many movies have been made in a time before we ever knew how to make movies? Relative to movies made in the era where we know how to make movies. You can do the numbers. It's small. Yes,
sure.
the Spartacus, there's the OK Corral.
Three Musketeers.
Those exist.
That type of stuff.
Okay?
Okay.
If we are any measure of the incentives of creating simulations, which all we can do with movies at this point, then they might have some historical but there's way more interesting things and stories to tell in the era
of simulations that exist post-simulation.
Right. Yeah.
So even if there are some period pieces that we might be, still most of these would be universes made after they could simulate themselves.
Right.
If our movie-making habits are any indication of anything.
So the chances are we're not a little offshoot, like a little side project.
We could be, just statistically, it's
Probably
not likely.
not. Right.
Because we're throwing darts.
Right.
And most of the stories they're going to simulate are going to be the ones that that are in the era of the time they could simulate themselves.
So that still brings us back to we're probably either the first or we're on our way to being the next.
On our way to being the next. That's
Right.
correct.
One or the other.
That's more likely than any other possibility here.
Wow.
And so I can now rest well at night.
So no simulation.
Yeah, I'm good. I think I'm real. I think you're real. I think we're good.
Well, real recognize real. So yes.
Does not care. What do you think unlocking the secrets of dark matter could do for us scientifically? Would it lead us to being able to harness it? Wow, those are two really big questions.
How old is he? Is he some kid in a basement trying to
figure something out?
Future superhero nemesis in the making.
He's making his own little universe or something. Can we harness
really dark gravity?
Right.
It's literally dark gravity.
Right.
We don't know if it's matter. The folks betting on it think it is matter, and there's a new kind of particle that we have yet to isolate. That's all. That's what that. So
All right,
if
so
we do
now-
isolate it,
Okay.
what would you do with it? Or, you put it in your hand. No, it'll pass right through your hand because it doesn't interact with your hand. All right. So I don't know how you would contain it.
How do you contain it?
You would need a dark matter box.
Right.
So who's going to make the dark matter box? I mean, it's a philosophical. If there's a thing that passes right through you,
How do you
contain it?
The thing.
The thing.
That
right.
you need to find something
thing
that
to
can
hold the
it.
thing in.
Right.
Correct.
There you go.
You need something that interacts not only with our forces, but also with its forces.
Exactly.
That could be yet another frontier of discovery in the universe.
What is that intermediary
In fact,
thing?
If you were that civilization,
right,
you'd be badass. Oh my gosh. You control not only all the universe that we know about,
right,
but the rest of the universe that's influenced by dark matter. You'd be able to grab it, make dark matter planets out of it, if you could make it stick to itself.
Mm-hmm.
So yeah, that would be a powerful posture to purvey.
Most of the matter we experience that makes up the stars of the galaxy only makes up about 5% of the content of the universe.
Correct.
Okay. If that's the case, you just said it is it possible that, given we interact with such a small percentage of the universe, we are indeed the anomaly? This really makes me feel weird.
Yes. So it's imagine you're at night and there's an ocean in front of you, but you don't really know it. And you turn on your light and you see these white caps, okay, which show up nicely on moonlight. And we are the white caps of an ocean that surrounds us. So, correct. We are, if there were beings made of dark matter, dark energy, they would see us as a contaminant in their universe, which, by the way, is a violation of the Copernican principle. Oh. Copernican principle says that we are not special in time or in place or in location. We're orbiting an average star in an average galaxy. So statistically, it says that we're average, but if we are contained within that 5%, of all the laws of physics, chemistry, biology, and all the ingredients that make up matter as we know it, then we are something unusual in the universe.
If we think dark matter as a giant spiderweb that holds the Earth and the sun and the gravity, why does it interact with dark matter that holds the Earth and the moon together? Or the dark matter that holds our solar system and the Milky Way in the galaxy? With normal matter, these three spiderwebs would scrape and break each other. Is there different dark matter that's doing different things?
Yeah, so dark matter is not holding Earth together.
Right.
The molecular forces are, the electromagnetic attraction forces are. Dark matter is not holding the solar system together. All the objects, there is sufficient gravity to make that happen. But dark matter is holding together the galaxy. And it's holding together galaxy clusters. So it turns out, other than through gravity, we don't interact with dark matter. So you could just walk through dark matter, you wouldn't know it, and it wouldn't know it. More
more accurately said, you wouldn't know it and it wouldn't care. Okay? So now, not only do you not interact with dark matter does not interact with itself.
Oh.
Because if it did, you would have concentrations of dark matter. Just think about it. If you have two hot marshmallows and they meet at night, okay, over the...
Right.
What'll do?
Well, they'll get it on because they're both hot. So, I mean, that sounds like a marshmallow love if I ever heard it. Two hot marshmallows coming together.
That was not my intent for you to take it down that path. So, two hot marshmallows, they'll stick.
They'll stick to each other.
So there are forces within marshmallow, material forces, that when it sees other marshmallows, that they'll stick. Okay? So our matter knows how to do this. All right? That's how you get planets.
Right.
That's how you get stars.
Right.
Dark matter does not stick to us, so it's not with the marshmallow or with the planet or with the star, and it doesn't stick to itself. So dark matter does not make concentrations. So as far as we know and understand the behavior of dark matter, you don't expect to see dark matter planets or dark matter galaxies.
Dark matter is the Unabomber. It's just lone. It's a lone wolf.
It's lone
out there by itself.
You know, this is a weird thought. The way stars are moving around the center of the galaxy, they would get flung out of the galaxy if it weren't for the dark matter providing the gravitational pull to keep them in.
Right.
So we desperately need dark matter, even for the Milky Way.
Vera Rubin first showed that.
Yes.
1976.
Yes. Okay.
That you figure out how fast all the stars are moving. So you're going too fast.
Right, to stay.
To stay.
You're going too fast
You have enough escape, and you're not escaping. And so some extra forces are holding it.
Right.
And behold this mysterious
dark
problem.
matter.
Yeah.
The word acronym is actually modern. It had only been created not much longer before the zip code was introduced. Just the word acronyms. An acronym is a series of letters that spell something you can pronounce. Okay, so IBM is an abbreviation, not an acronym. CIA is an abbreviation, not an acronym. SCUBA is an acronym, self-contained unordered brain. You all know that. NASA is an acronym because you can say it. So I looked this up, and then I keep historical dictionaries, and I found a dictionary from 1947. The word wasn't there. And it was like, whoa, how could that not? And so that was my exact reaction. And then I learned there were so many abbreviations that came out of the Second World War that all of those that spelled words, we invented a word for those that spell a word, and that was acronym. The higher dimensions that some are sort of compactified so you don't notice them. So I'll give you an example. If you put an ant on a sheet of paper, the ant can only really go in two coordinates, right? Okay. X and Y on a piece of paper. But the paper has thickness, but that's really not important to the ant.
Right.
So it's possible to have more dimensions than you realize. They're just sort of hidden in a way that you don't really interact with them in meaningful ways. So the string theorists, of which Brian Greene counts himself among their ranks, have suggested that, and others have suggested that the actual universe, the real universe that we live in, we only experience 3 spatial dimensions and a time dimension, but in fact, there are other dimensions that are essentially hidden from us.
What do you think are the odds that there is life elsewhere in the universe?
They must be high, and I'll tell you why. People say, well, have you found life yet? No. Well, that's like going to the ocean. This has been said before, taking a cup of water, scooping up and saying, there are no whales in the ocean, you know? Here's my data, you know? You need a slightly bigger sample. If you look at, for example, what we call the radio bubble, this is the sphere around Earth, centered on Earth, which is the farthest our radio signals have reached in the galaxy. And they're about 70 light years away. We've been transmitting radio signals inadvertently leaking into space for about 70 years. 70 light year radius sphere. Well, how big is the galaxy? Well, shrink that sphere down to maybe the size of a BB, and then the galaxy on that scale would be the size of this stage. That's how far our radio signals have traveled. And those aren't even the ones we sent on purpose. The ones we sent on purpose have traveled much less. So no, we haven't actually reached as far into the galaxy as we'd like before we would say definitively that there's no one intelligent living today. But here's some very simple facts. I can review them in 90 seconds. You look at the formation of the Earth, and the earliest sign of fossil life. Subtract a few hundred million years at the beginning of Earth, when Earth was a shooting gallery. Earth was still accreting the birth materials of the solar system. It's hostile to complex chemistry over that time. Not fair to start the clock then. Wait a couple of 100 million years, now start the clock, and wait around and see when you have the first signs of single-celled life. At most, 400 million years. At most. Earth has been around for 4.5 billion. So Earth, without any help from us, with basic ingredients found throughout the universe, managed to create life, simple though it was. So, and Earth, one of, 8 planets, get over it. One of, sorry. And what are the ingredients of life? The number 1 atom in your body is hydrogen. Number 2 atom is oxygen, together making mostly water that's in you. Next is carbon in this order. Next is nitrogen. Next is other stuff. My favorite element, other, yeah. You look at the universe, the number 1 element in the universe is hydrogen. Next is helium, chemically inert, couldn't do anything with it anyway. Next is carbon. I think I left out oxygen there. Next is oxygen. Next is nitrogen, 1 for 1. We're not even made of odd things. The most common things in the universe are found here on Earth, and we're made of them. And carbon, one of the most chemically fertile element on the periodic table. It's not a surprise. We're carbon-based. Life is just the extreme expression of complex chemistry. So that's what biology is. So all these people who want to imagine, because they remembered their chemistry class that silicon sits right below carbon on the periodic table. So it bonds similarly to carbon, so they want to imagine silicon-based life. I'm saying, okay, fine, but you don't have to. There's 5 times as much carbon in the universe as silicon. There's no need to even have to go there. We got enough to imagine just simply with the carbon atom at the center of these huge biological molecules. Point is, it happened relatively quickly with the most common ingredients in the universe. To now say life on Earth is unique in the universe would be inexcusably egocentric. When you are in free fall, you are weightless. Now, if you're in an elevator and you cut the elevator cable, up until the point you hit the bottom, you are weightless. You're in free fall. Here's an experiment you do. It's a very cool, cheap experiment. Take a tall glass of water, punch holes in the side. Obviously, the water's going to leak out. The water at the bottom hole will spew out farther than the water in holes higher, because the water weighs more above it. There's more pressure at the bottom to spray the water out. So the bottom one is far, and the higher ones are a little less. It's all because of water pressure, the weight of the water. Take that cup of water while it's spilling, drop it into a sink. It doesn't matter what you drop it into, but this is to minimize mess. Drop it. The instant it leaves your hand, it is weightless because it's in free fall. The cup is weightless, the water is weightless. And if the water has no weight, then the water does not know to exit the hole in the side of the cup that you punctured. So the instant you drop that cup, the water cuts off. It just stops. And the cup falls, hits the bottom, and spills in your sink. But while it fell, it is evidence that the water became weightless. The apple is weightless, the moon is weightless.
Remind us of the many worlds hypothesis.
When we teach undergraduates quantum mechanics, we say that a quantum system has 2 different ways of evolving. There's one way it can evolve when you're not looking at it. And that's what Schrödinger and Heisenberg and their friends figured out back in the day. But then there's a whole nother way that we need to describe that behavior when we make a measurement, when we observe the system. Famously in quantum mechanics, you can't predict deterministically, precisely, with 100% confidence what answer you're going to get. You can predict a probability distribution over different possible answers. What is this going on with this weird thing? You don't expect measurements, observations, looking at things to be part of the fundamental nature of reality, right? It never was before quantum mechanics came along. So you can ask yourself, what if all of that was unnecessary? This whole idea that we need a separate rule for what happens when we measure something? What if you just erase that from the rules of quantum mechanics? And the answer is that what you find is that every possible measurement outcome comes true, but in a different world, in a different part of the overall quantum universe. You get parallel worlds where different measurement outcomes are true.
So these different worlds are in the same realm? Is that the case? Or are we talking about completely different unfoldings that create completely different scenarios that make the whole thing work?
Or another way to ask that, do you have access to these other worlds?
You have an iPhone, you can download an app called Universe Splitter. And if you're ever stuck on what decision to make, should I have a hamburger, should I have pizza for dinner tonight or whatever, ask the Universe Splitter and it will come back with an answer, and you can be guaranteed that there's a whole nother universe which you can never interact with or talk to, in which you do the opposite thing. So
it's split in that instant.
Right.
In that instant, yes.
Yeah, at the decision instant.
Okay.
It's a physical quantum process.
But and that's because of the entanglement, because they couldn't exist simultaneously. They have to exist in those positions at the time of the decision, so that when one does it, the other does the opposite, or when one does something, so there's an action and there's a reaction, but there can't be action. It has to be so that they're existing and then reacting differently. Is that
Sean, Chuck is about to blow a gasket.
And no, because you're freaking me out, man. You are freaking me out.
This is not anything that we bump into in our everyday lives. If it doesn't make you a little bit uncomfortable, you're not taking it seriously.
What's the latest thinking on dark matter, dark energy? Are you all in on the particle thing? You got some other exotic?
I'm happy for it to be a particle. I've proposed theories where it's not a particle, but they're not very good, these theories. The dark matter is probably kind of a particle. We haven't found it yet, and I would say that, we had a chance of having found it already. The experiments are pretty good, but it wasn't like a 99% chance. It was like a 50% chance we would have found it already. So the fact that we haven't found it already is not yet cause for concern.
Okay.
The dark energy is interesting. Again, I've written papers about different possibilities for that, but the simplest one is the best. Einstein's idea that there's energy in empty space. It's just a fact of the matter. Every cubic centimeter of space has 100 millionth of an erg of energy inherent in space itself.
Erg is a unit of energy.
Pushing the universe apart. And so we don't know. In fact, there was a provocative recent result from the Dark Energy Spectroscopic Instrument, which claimed that maybe the dark energy is declining very slowly.
At DESI.
So we don't know. That'll be very, very fascinating and exciting.
That the dark matter field is changing.
Dark energy field is slowly declining with time. Yeah.
Declining. Now, is that allowed if the Einstein's cosmological constant, which was our first indication that there might be this thing such as dark energy working opposite gravity, that is identically a constant, the way it comes out of the equation.
That's right. So if this is true, then the cosmological constant is not the dark energy. The dark energy is something else. The cosmological constant, the vacuum energy, which are equivalent, that was a candidate. That's one possible thing the dark energy could be.
Got
the
it.
simplest,
I
most
didn't
basic
appreciate
thing.
that.
Yeah.
And it's a leading candidate because it comes out of we're using the equation anyway, and it was already there.
That's right.
And
everything else is a little bit more delicate, a little more fragile, hard to figure out, but cosmological constant's pretty easy. Just put it in there.
If you think that free will is somehow an ability of human beings to not be guided by the laws of physics, then you were in trouble long before quantum mechanics came along, okay? I don't think that quantum mechanics is very relevant here. All quantum mechanics says is we can't exactly predict what the outcome will be, but there's still laws that say what the relative probabilities are. So I really don't think that quantum mechanics it conflicts or helps free will in any way. That's a separate philosophical problem.
Could it be that what we perceive as free will is some version of the probability space that quantum mechanics grants its particles?
Well, I would say that's almost exactly true, but you don't even need quantum mechanics to say it. You could just say it classically. You don't know the position and the velocity of every molecule and atom in your body. So when we talk about human being, this is what is called the compatibilist view of free will, which is the most common one among philosophers. When we talk about human beings, of course we talk in a language of probabilities and choices and volition and willpower, because we are not perfect calculating machines that can say exactly what's going to happen. So it makes perfect sense to talk about the free will that people have, not because they're able to overcome the laws of physics, but because that's the best way we have of describing them in the real world.
Okay, so our perception of what's going on is completely compatible with the idea that we have free will.
Yes.
Physicists
It's your personal truth.
can't agree on what quantum mechanics really said. So we have this idea that everyone uses in quantum mechanics, Hilbert space, which is the space of all possible imaginable quantum states of the universe. And someone like me, who is a purist and extremist about this, says we have all possible quantum states. The actual universe is one of them, and it changes with time. Other people will say, no, that's not reality. That's just a tool we use to describe predictions, to, make predictions for experiments. Other people will say that's part of reality, but there's other parts as well. We don't have a consensus on this.
Okay. I like the absence of consensus.
Yeah, exactly.
It wakes you up in the morning. How do you square all the successful predictions of quantum physics with any intuitive understanding of what's going on? Because I've said many times, and I'm happy to say it again, the universe is under no obligation to make sense to us. So once you accept that, why try to make sense of it? And jump through hoops and brain twists just to say, well, it's got to be this or it's got to be that. But it calculates and it works. Move on.
The universe is under no obligation to make sense, but remarkably, it keeps making sense. Once we really let ourselves listen to what the universe is trying to tell us, the universe seems to be intelligible. It's not deeply, ineffably mysterious. And it's a give and take. It's not like our intuition just maps on to reality. Reality is like, nope, your intuition was a little bit off there.
Yeah.
Try to update. And if you're open-minded about it and you buy the right books, very updatable. You can absolutely get there, is what I'm saying.
Do you remember that case in New Jersey where there was the middle school student who tape recorded the history teacher saying that the students will burn in hell if they don't believe in Jesus Christ? Do you remember that? And it became a whole hullabaloo in the district, and it would say separation of church and state. This is a violation of the First Amendment, or Second, whichever amendment, okay? First Amendment, separation of church and state. And everybody got up, and the ALC, the American Civil Liberties Union, everybody's jumping arms about separating church and state. And I'm saying, among the statements made by this teacher were that the Big Bang and evolution were not scientific theories, and that Noah's Ark carried dinosaurs. Now, so, at some point, I said, I can't keep listening to this. And I wrote a really short letter. Short letters are the best, I think. And all I said was, after two other letters rambling on about keeping religion out of the school because of the amendment in the Constitution, I said, this is not an issue of the separation of church and state. No, you got that wrong. This is an issue of the separation of ignorant, scientifically illiterate people from the ranks of school teachers. And so I cited, in defense of that line, his comment about the Big Bang and evolution and dinosaurs with Noah's Ark. I did not cite in that his assertion that Jesus Christ is a savior, because not much I can say about that. But to pretend that the rest of this information, that he's accurate in this information, that's a travesty. That anyone who calls himself a teacher would believe that as factual information about the history of the world. That's when I jump up and I have something to say.
Rome, when they built streets, they didn't call them streets, they called them ways. And you look up at the night sky and you see this milky band of light. They just call it the Milky Way, the Milky Street, literally. In China, where milk is a less popular beverage into adulthood, they don't call it the Milky Way, they call it the Silver River. And it would not be until Galileo did we learn that when you put a telescope on the Milky Band of light, it reveals itself into stars. So we say, wow, all right. But is this all there is? Just stars in front of our face and then the stars that are far away that make this band? It would take until 1920 before we resolved the debate about whether the spiral fuzzy things in the night sky were actual other galaxies separate from our Milky Way. We now know there's nearly 100 billion galaxies in the observable universe, and each galaxy has hundreds of billions of stars on average.
We've been fed a lie I want to call it a lie. Earth has been misrepresented to us by geologists because the globes that you buy, that you rub your fingers over and you feel the Himalayas and you feel the Rocky Mountains. No, okay? These mountains are
puny compared to the size of the Earth. You would not know they were there. If you were truly that size, some big cosmic giant lumbering through space, coming upon the Earth, rubbing your hand on it, the depth of the fingerprint mark, the depth of that would be greater than the entire range of distance from the Marianas Trench in the bottom of the Pacific to the top of Mount Everest. Therefore, you would close your eyes, rub your finger, you would not know whether you are on ocean, valley, mountain, or hill.
Well, you might be wet or dry. You might be,
well, by how much wet?
A little.
How? No.
Yes.
You wouldn't even notice it. You're not going to say, oh, I got to dry my hand. The depth of the ocean doesn't measure up to the depth of your fingerprint. That's my point. So we've been fed this misrepresentation of our own planet on the belief that, in fact, we have real surface features. But cosmically speaking, we're practically a perfect sphere.
I once taught a class at the Hayden Planetarium, evening class for adults, and someone in there at the end said, I got to level with you. I cast horoscopes. I just wanted to learn more about astronomy. That's great. That's fine. And so she said, I can cast your sign. And I said, really? Okay. And she said, well, what's your sign? And then I asked her, well, if you're really into this and you had me for 12 classes or 15 classes, you should know the sign. If all this works the way you say, if it's so inevitable, it should be obvious. Yeah. She said, okay, you're a Cancer. And I said, no. So, okay, a Taurus. No. And then like 8 signs later.
It's like halfway through.
No, more than halfway.
More than halfway.
Yeah, 8 is more than 6 of 12.
6,
okay. So it was like the 9th guess. She said, you must be a Libra then. And I said, yes, a Libra. I knew it.
You're like, no, you didn't.
Okay. So here's what's going on there. Okay. So I've done this experiment. I invite you to do it. If you're in front of a big group of people, pick a well-read horoscope for that day. In a magazine or the app or whatever. Pick one at random and read it to the audience and say, whose horoscope did I just read?
And everyone's going to
2/3 of the hands will go up. And then say, okay, for those you are certain I didn't read your horoscope. Okay, no, of those how many of you are certain it was not your horoscope? And they'll raise their hand. And then you tell them, and almost every case I've done this, people were certain it wasn't theirs, it was some of theirs. Yeah. And of course, it's not most of it. It can't be.
Right.
Okay, at most it's going to be a 12th.
Right.
So the point is, that's another confirmation bias going on. You ignore everything in the horoscope that does not apply to your life.
When going to a different planet, what aspect of traveling will be most important?
Great question, and there's a lot of thinking about this. They worry about food. Not only is there enough food, but will you like the food? If you get bored with the food, will that affect your morale? And then you're less effective doing other tasks. Do you need comfort food? Do you want exotic food, international food? The water supply. Is there enough water? Do you recycle the water? If you recycle the water, that means it collects all of your urine, filters it, and then you drink it back. Is that too freaky for you to do? Other things, the time in a close quarters with only 1 or 2 or 3 other people, months and months, and in some cases years. Can we remain emotionally stable over those times? There's the fact that if you fly without creating artificial gravity, that you are weightless the whole time. Are you perpetually motion sick, or do you get used to it? And if you get used to it, are there any other factors on the body? We already know some of the answers to that. You begin to lose bone density. You have the bones of a frail old woman. All of these factors have to come together, which is why you can't just send any old person into space.
So I have a sample of aerogel in this office.
Really?
Yes.
I have never touched a sample of
You've
aerogel
never touched
in my
aerogel?
whole life.
Really?
Always wanted
This will be a first for Adam Savage.
Dude.
It'll be a first for everybody. What the hell is aerogel?
Aerogel is the most ghost-like solid substance ever spun.
And it's like 99.9% air, right?
Yes. Higher than that.
Oh my
gosh. So here it is.
Oh my goodness, look at that.
I said it's like a ghost.
It does look like a ghost.
Okay.
You brought a tesseract
out.
Hang on.
No
way. Hang on. Way. Okay. Look at that.
Oh my. Okay, that is one of the coolest things I've ever
It is like
seen.
ghost.
It is.
It's actually solid. Right? It's not flexible.
Right.
It's very brittle.
It is science cotton candy.
Don't eat it, Chuck. Come here. Ready?
Wow.
That is aerogel.
Look at that.
That's. Oh my God. I can feel that it's.
You can pick it up. I trust you. It's like a ghost.
Look at that.
It might be the lowest density solid stuff ever. And it's used for NASA. And the aerogel is has many applications. One of the ones that we care most about is you put that on a spacecraft, on a space probe, and as it flies through a comet's tail, particles of the comet enter the gel, and it slowly stops it so that it's intact by the time you bring it back and then analyze it. It also has highly insulating properties. It's like one of the most insulating things ever known. And the way they make it, they have some polymer chain that they spin up, and it's this solid thing, but then they evaporate all the liquid. And what's left are the molecules that flesh out the volume that the liquid once occupied. What people? Those that say, well, we're spending these people. Okay, and so how much do you think NASA's getting? Here's your tax dollar. Pull out $1. Here's your tax dollar. How much are they getting? Okay, and here we go. Got my $1. Oops, that's a 5. Wait a minute. Oops, that's another 5. There we go. $1. Tax dollar. How much? Here's your tax dollar. Is it 10 cents, 20 cents, 30 cents? How much is NASA getting? It is getting 1/2 of 1 penny of this tax dollar. 1/200th. That's not even, you're not even in the ink yet. Here, you're in the edge. That pays for the rovers, the space station, the space shuttles, the Hubble telescope, all the NASA centers, NASA headquarters, all of that. And I ask you, how much is the universe worth to you?
If we left right now, it would take us 9 months to get to Mars?
No, you can't leave right now. You have to leave when Mars and Earth are properly aligned. So just to remind people, if you see Mars in the sky and you start traveling to it, no. You have to travel to where Mars will be when you get there. So it's a matching of trajectories that matters here. So what we call the minimum energy trajectory. So it's one where you burn your engines and then you shut them off, then you coast to Mars until Mars pulls you into its gravitational influence, and then you fall towards Mars. That takes about 9 months. But if you run your engines the whole time, which we can't do yet because we don't know how, because we don't have enough fuel, if we have filling stations along the way, you could do this. If you do that, you get to Mars in weeks, a few weeks. But it'll take a boatload of fuel to do that.
Was Galileo treated as a kind of a devil, in a sense?
The simple story is he makes these discoveries. They conflict with the teachings of the Catholic Church. They put him on trial. They find him guilty of saying that Earth goes around the sun and not vice versa. And then they put him under house arrest. What they don't tell you, or they would tell you if you read a longer biography about him, is that he actually made fun of the Pope, public fun of the Pope. He wrote a book in Italian, not in Latin, which is the academic language of the day, in Italian, which means the local people can read it. And in it, he invents a conversation between a simpleton and someone who is wise of the ways of the universe. And if you track the statements of the simpleton, they're all statements that have come by official decree from the Catholic Church. So he's really a pompous a-hole, basically.
Oh, by the way, in the distant future, as we continue to expand, galaxies will expand beyond the horizon that we have established from our location here. So what is that horizon? That's where they're moving away from you faster than the speed of light. Right. So their light tries to reach you, but it can't. It can't.
Wow.
All the energy gets sucked out of it. And so every galaxy in the night sky will go beyond that horizon. Okay? Wow. With or without its stars, it'll go beyond the horizon. So if we look outside of our own galaxy, there'll be nothing there. As far as we know, our entire universe is just the stars, living or dead, in the Milky Way.
In the Milky Way. Oh, that's...
So our entire understanding of cosmology in a post-apocalyptic civilization, in that very distant future, will have no idea the universe had a beginning at all, because we know about the beginning by looking at other galaxies.
Right.
So a page in the history of the universe will have been removed, and they will not even know it. One of the active ingredients in the smell of a fart is hydrogen sulfide. It turns out hydrogen sulfide is extremely lethal, is one of the most lethal gases that exists. Well, why do we have such a good sense of smell for that? Why don't we smell other gas? Why don't we smell nitrogen? Well, we don't need to smell nitrogen because it's not going to kill us, because it's 78% of what you breathe anyway.
we have evolved a hypersensitive sense for the smell of hydrogen sulfide. If you gave birth to someone who said hydrogen sulfide smells beautiful and let's smell more of it, let's get canisters of it, they're dead 10 minutes later, no longer able to propagate the gene that liked the smell of hydrogen sulfide. It has been theorized that there have been places and times on Earth where the ocean currents stopped. And when ocean currents stop, oxygen at the surface of the ocean never makes it to the bottom. So you can't sustain oxygen life forms at the bottom of the ocean. There are no fish. There wouldn't be any fishes down there if the ocean currents stopped. Because the ocean currents not only go from one place to another in the world, they circulate top to bottom, right? So it's a two-dimensional thing going on, 3 dimensions actually. So if something happens on Earth where you stop the oceanic cycles, you can create a condition in the lower ocean where anaerobic life forms thrive. And if they thrive, they outgas. And one of their outgases is hydrogen sulfide. It will gurgle up from the bottom of the ocean, rise up near the shores, turning shorelines into the smell of cesspools. If you were alive at the time and didn't run away from that, you would have simply died from it.
If you really want to levitate, if this is really important to you, I tried to calculate how many cans of beans this would require. Then you got to kind of hold it in.
Yeah. Right.
Then let loose.
Suddenly.
Yes. And in principle, for the duration of the thrust, you can levitate briefly.
What scares you most about civilization?
We're losing our capacity to distinguish what is true from what is not, what is objectively true. And the methods and tools of science are exquisitely designed to establish what is objectively true. And objective truth is, I perform an experiment, I get a result. Other people perform other experiments, get the same result. It repeats, there it is.
Line up 1,000 people and give them a coin. And everybody flip the coin. And about half will get tails, half will get heads. If you got tails, sit down. That's 500 left, approximately. Have them flip. Half get heads, 250 of you sit down. Now we're left with 2. Do it again. Go from 250 to 125 to 60, 30, 15, 8, 4 to 2 to 1. Okay? In this experiment. It's not an unthinkable experiment. This person who survived this exercise flipped heads 10 consecutive times. Now here's what journalists do. They go up to that person and they say, how do you feel? Well, I knew I had felt that head's energy halfway through, and I was feeling it, and did they ask anyone else if they felt that head's energy? No, they only interviewed that guy. Okay? I'm not done. Essentially, every time you do this experiment, somebody's going to flip heads 10 consecutive times. So you want to say, oh, this is a special universe in which that happened? No, because of the nature of the fact that you have 1,000 experiments happening all the time, there's going to be one where somebody flips heads 10 consecutive times. Every time you do this experiment.
More molecules of air in every breath you take than there are breaths of air in all the atmosphere of the Earth. So that when you exhale, there's enough of those molecules to scatter. And the air currents will do this, to scatter into every breath of air that is inhaled. When you take a breath of air, you have molecules of air that went through the lungs of Jesus.
In the early universe, there was so much energy, every particle could be made. So watch what happens. You have a pocket of energy, it becomes mass. And the only way we know that can happen is if it becomes a particle and an antiparticle pair, matter and antimatter. So the opposite of an electron is a positron. It looks just like an electron, but among other things, it has the opposite charge of an electron, positron. Okay? Every particle has an antiparticle. In the early universe, the temperature was very hot. And above certain thresholds of temperature, what happens is matter no longer stays as matter. It can freely move back and forth between itself and energy. And we have the recipe for this. It comes from E equals mc squared. We all know that equation. It's the formal conversion recipe for matter and energy. And the c squared is the speed of light squared. It's a huge number. A little bit of mass times that huge number gives you a lot of energy. We don't experience in our lives E equals mc squared because the energy in which we're immersed is not high enough to enable matter to go back and forth between energy and itself. That's why it took so long to discover E equals mc squared and to come to terms and to come to understand it. If you take matter and antimatter and put them together, they annihilate and become pure energy, and the matter disappears entirely. You take the particles, matter, antimatter, identical particles, except that they're matter, antimatter, bring them together, they disappear. And that matter becomes energy, and all that's left is energy. Right in that pocket, right there. Newton comes along, writes down equations of motion, equations of gravity, and kind of on a dare, he invents integral and differential calculus. Then he turned 26. This is why Isaac Newton is my man.
Okay, will you allow me one conspiracy theory?
Delicious.
Will you allow me one?
You get
Okay.
one.
You ready? Okay.
Yep.
We had people who wanted to go back in space, but we needed an adversary. And we knew at the rate China's economy was growing, that if we don't invite them on the space station, they'll build their own damn space program. And it's exactly what they did. And within years of that, 10 years of that, they sent their first taikonaut into orbit, plans to build a space station. They're landing craft around the solar system. And now they're talking about sending astronauts to the moon. And all of a sudden, here in the United States, we say, I think we should go back to the moon. Bada bing. We now have the Artemis program. That's my conspiracy theory.
So let's talk about the scene of dark matter from your show at the planetarium.
So what's going on here is you're viewing the structure of the large-scale universe. And what we've represented here are dark areas that themselves have more gravitational attraction than the light areas. So the light areas are drawing themselves to the dark areas. And so what happens is, as this happens over the eons, structure begins to manifest in the universe. And you see this web work, and it looks almost organic, or it looks like some kind of neurosynaptic map. The formation and collection of matter in the universe follows the laws of physics, and when you add in the dark matter, this extra gravity, it turns the universe into the universe that we see. That's why we know the dark matter is real. We don't know what it is, but we know it's there because we can't make the universe as we see it unless we put this extra gravity into our simulations to match the gravity that we see. And there's some exotic ideas for it, by the way. Particle physicists are convinced that it might be an exotic particle that doesn't interact with us, doesn't interact with our light, or with our telescopes, but that it has gravity. So these particles are doing their own thing, invisible to us, but otherwise attracting our matter into nucleating us among them. So, but of course a particle physicist would think that the solution is a particle. If you're a hammer, all your problems look like nails. One of the more intriguing accounts I've heard is if you have multiple universes, it turns out gravity can spill out of one universe and be felt by another. And if we have another universe adjacent to ours, it could be that these sites where we see extra gravity is ordinary gravity in a parallel universe. And here we are looking at it mysteriously, like, it's like the blind man touching the elephant. I don't know what this whole thing is, but here I can describe this part of it. And it's kind of textured, and it's smooth and hard. And you can't see the whole elephant. Maybe the elephant is ordinary gravity in another universe, and we're feeling it, and we're making stuff up just to account for it. Dark matter doesn't interact with us. It kind of also doesn't interact with itself, or does it?
Oh, yes, it does. It annihilates. So when two dark matter particles hit each other, they annihilate, which means they turn into something else.
Then how can you make an object out of dark matter?
I don't make an object out of dark matter. Do you make objects out of dark matter?
I thought you made a dark matter star.
No, dark stars are made almost entirely of hydrogen and helium, 99.99%. And it's a little bit
Which
of
is
dark
regular,
matter.
like all stars, like all stars in that. Okay.
And no, it's only hydrogen and helium from the Big Bang because these are the first stars that ever formed.
Got it.
So they don't have anything else in there. No carbon, nitrogen, oxygen.
No, all I meant was all stars have hydrogen and helium in them. That's all I meant.
Yeah. So it's ordinary matter, but it's powered by dark matter because you have a lot of dark matter in there, and those
left over from the early universe.
Okay, let's back up. The dark stars would have been the first stars to form in the history of the universe when it was 200 million years old, and we're now at 14 billion years.
And this is your baby, these dark stars.
That's my baby.
You birthed these.
This is my baby.
Yes, okay, go on.
Yeah. And back in the early universe, these things formed at the centers of protogalaxies.
Yes.
Small objects that are going to merge together to make our galaxy
That's where the action
later
was.
on.
The gravitational action was.
Yeah. Smack in the middle of these protogalactic objects, they're called mini halos. That's where you would have collapsing clouds of hydrogen that are on their way to forming stars. In the standard picture, they keep collapsing and make tiny little objects a thousandth of the mass of the sun, and then it creep back up to about 100 times the mass of the sun. But nobody asked, well, yeah, but if you're smack in the middle of the protogalaxy, what about the dark matter? What does that do?
Right.
So that was a question that we asked. And
you would be enclosing some volume of dark matter in doing so.
Well, there's a lot of dark matter at the center of our galaxy, at the center of the protogalaxy.
Okay.
The fact that you're smack in the middle is what counts.
Got it.
Because that's where you got a lot of dark matter.
Got it.
And when you got a lot of dark matter, annihilation.
And why the coalescence of dark matter at the center?
Because it responds to gravity. We knew that.
Oh, that's right. Because at the center of every galaxy, there's a black hole. Is that the deal?
No, it doesn't matter about the black hole.
Doesn't matter about the black hole.
No,
Okay.
it's just to go to the center of any massive object, a galaxy, a cluster, anything, that there's a ton of dark matter in there. And then as you move out, it gets less and less dense in terms of the dark matter.
There are more water molecules in this cup of water than there are cups of water in all the world's ocean. That's how small molecules are. So what that means is if I take this and toss it out, there's enough molecules in what I toss to enter every other possible cup of water anyone draws from the world's water supply. There's enough to scatter to every possible cup of water in the world. So if I drink this, it comes back out of my body in some way or another, any one of a half dozen ways. That re-enters the environment, goes to clouds, it goes to the streams, goes to the oceans, and given enough time, it mixes completely. So, Socrates drank a glass of water. It is a certainty, it's essentially a certainty, that some molecules that passed through his kidney were in that glass that you just drank. And it's not only that, by the same reasoning, there are more molecules of air in every breath you draw than there are breaths of air in all the Earth's atmosphere. So by the same calculation, every breath you take, some of those molecules pass through the lungs of whatever is your favorite historical character, Jesus. You want to think of us as separate and distinct from one another or not connected to the world, but we are. And for me, what I think of as fascinating ways.
If you look up at the night sky, almost half of all the dots of light you see, if you pull out a telescope, will reveal themselves to be binary or triple star systems. Wow. It is as common as the breeze in the universe. The challenge here is, what happens to a planet in orbit around a binary or multiple star system? That's the challenge.
And is the atmosphere stable enough to support a life?
That would be a concern no matter where the planet is. But here's the challenge with a multi-star star system. As the planet orbits, maybe it'll get really close to one star and really far from another, and maybe the orbit is entangled between the two of them, trying to do figure eights. If you have an unstable orbit, you're likely to eject the planet forever into interstellar space. And in fact, data are now showing that interstellar space may have more rogue planets that have been ejected for having misbehaved orbits from their star systems than there are stars within planetary systems themselves.
Dude, you just blew my mind.
And they're called rogue planets. I'm just beginning here. So watch. We also know that many planets have still retained their heat of formation long after they've come into existence. Earth still has heat churning, a source of energy that is not traceable to the sun. This is what creates the magma that's sitting below Earth's crust. The sun didn't heat that. That's heat generated within the Earth. Some is left over from formation, others is created from radioactive decay of elements, but we've got an energy source. And our biology books from decades ago said life needs sunlight. No. Life needs energy. It doesn't care if it comes from the sun. The fact that we've discovered exotic life on Earth has broadened the net that we have cast into space in our search for life in the universe. No longer do we need to look for the 72-degree pond in an oxygen atmosphere planet in our search for life. So this Goldilocks zone where everything had to be perfect, we've got life thriving in places that would kill us. We are not the measure, the ultimate measure of what the conditions that life requires to survive. So now that we're looking with this very broad net, we can say to ourselves, for these vagabond planets, if they still have their source of energy churning within, maybe there's life there. And if that's the case, the galaxy could be teeming with life, and the fact that we're focusing our search on planets around stars may simply be limiting all that we can discover in the cosmos.
If I had hair on my neck, it would be standing on edge as I see the depth to which he was connected to the operations of nature. There is no doubt about it. The man discovered the laws of gravity by sitting there. Okay, it's rumored that he sat under the apple tree, but what is certain is that he knew in the same field of view, he saw an apple drop and the moon in orbit around the Earth. Okay, he sees the two of them. One is falling to the ground and the other is like up there in space. He connects the two and suggests that the same force of gravity is operating on both of them. They're both falling towards Earth. He hypothesizes, well, how's that possible? Because I can drop this camera on the ground, they would fall. Okay? But if it's in orbit, it's not falling. But it is falling. It is. If you're in orbit, you are falling towards Earth. He suggested, suppose you had a hill and you sort of fire a cannonball. Not very fast. It would just sort of kind of fall, right? Fire it a little faster. It goes farther before it hits the ground, doesn't it? Even faster, it'll go even farther. Now, wait a minute, Earth is curved. So if you keep this up, this thing is coming around the backside of the Earth. So he asked himself, there must be a speed sufficiently high so that that cannonball comes right back to the cannon. And all you have to do at that point is duck. And the cannonball ought to just slide on by and stay in orbit. The fact is the cannonball is falling every moment it's there. The difference is it's going sideways so fast that the amount that it has fallen is the same amount that the Earth's surface has curved away from it. That is the speed that gets you orbit. He figures this out. And that's why the moon is behaving the same way the apple is. The apple just doesn't happen to have sideways motion to bring it someplace other than right below.
Who do you think is the most extraordinary scientific mind that that humanity has produced?
There is no contest. Isaac Newton. Nobody comes close.
Explain why.
He, working alone, discovers the laws of motion. Then he discovers the law of gravity, universal law of gravitation. Oh, and then someone asked, why do your planets orbit in this shape, ellipses, the ovals, rather than perfect circle? I said, I don't know. I'll get back to you. And he goes home, and he comes back. I finally have my answer. And he said, well, Isaac, how did you do that? Well, I had to invent integral and differential calculus to answer that question. He then discovers the laws of optics, deducing that white light is composed of colors, because you could take those same colors, recombine them, and get white light, which freaked out artists of the day. So he does all of this. Then he turns 26.
Is it true that you get more wet when running in the rain than if you walk?
So that's a fun question, and I've thought about that my entire life. If you walk in the rain, the only part of you that's getting wet is the part that's falling directly on top of you, so your shoulders and the top of your head.
Hence the umbrella.
So you get that area,
right?
And you look at the raindrops per minute that's hitting that area and how fast you're walking across the street. You can calculate that and get a total number of raindrops that you hit if you go slowly. Now, if you run, rain is still going to hit you on your head and shoulders, but for not as long.
Right.
But now you have your entire surface area of the front of your body that's running into falling raindrops.
Right.
Do you know how many stars the naked eye can see at night? It's about 3,000 to 4,000.
Oh, really?
Unaided, yeah. Binoculars, it's 100 times that.
Yeah.
Telescopes, it's 1 billion times that. But eyes, 3,000 to 4,000 stars.
Okay.
When it's a full moon out, 300 stars.
Yeah. Right.
The moon wreaks havoc on our ability to see the rest of the universe. So our observing schedules with huge telescopes are split according to dark time or bright time. And if you have bright time observations, it's the moon is up and you can only look at bright objects in the night sky.
Wow.
The deep universe only comes to us when the moon is not up. So what they decided to do is for people who are about to die, they would write a message facing upwards to the ceiling above the bed and suspend it there. So if a person goes above their bed and looks down, they'd be able to read the message. So when they rejoin their body, they should then tell us what message they saw. That's never happened. It's just... Now, I have a cousin who, when her father died, was alone with him in the room, and he's in an open casket. And she's otherwise completely rational, okay? I'm not saying this is a crazy person. She's a real estate agent. She tells me of a conversation she had with her dead father. And I said, was it in your mind? No, he sat up and spoke to her. I said, what was the conversation? And she said, well, he said, don't worry about him. He's in a better place, this sort of thing. So this is her eyewitness testimony. I'm not going to say it's wrong. I'm just saying it's not scientifically useful. I told her, next time this happens, ask these questions and not those questions, okay? Don't say, are you happy? No, saying, are you wearing clothes? Where are you? Where did you get your clothes? What temperature is it? Just ask questions. Like, this is an amazing scientific experiment you could be performing. That's my lesson to all of you, that if you find yourself in that situation, okay? Because if a dead person sits up and starts talking to me, oh my God.
I have very high experience looking at the night sky and the day sky, knowing what can happen in the night sky and in the day sky. I have seen things which without this extra background that I have, I would have easily reported as a UFO to the police department. But because I've studied phenomenon of the sky, I could identify it. There are clouds that build above mountaintops that take circular form that are very high altitude. If the mountain is high, the cloud is even higher. They're called orographic clouds. Some are called lenticular clouds, but these clouds are very high up. They can have perfectly cylindrical shape. Now watch what happens. The sun sets. You're at the bottom of the mountain. The sun sets for you. It hasn't yet set for those high altitudes because they can see beyond your horizon. So the sun is still there for them. It gets dark for you and the cloud is lit by sunset colors. And it's vibrant and it's circular and it looks for all the world like the mothership just came and docked over the mountaintop. If you are susceptible to wanting this to be true, then that for all the world is the mothership.
Your weight is not only how many molecules you have in you.
It's the density.
It's also what's the force of gravity operating on you. So you'll weigh more, but you won't look heavier. You'll just be heavier.
So my mass will be the same.
No, mass will be the same, correct. But your weight can be less or more, depending on what planet you're on. In fact, it's less or more on Earth. If you go to the equator and the equator is spinning, at the equator you're moving 1,000 miles an hour. You weigh less on the equator than you do here in New York City. You weigh less on a mountaintop than you do in a cave.
We should go to the equator, guys. Why do sodium and chloride, two extremely toxic and harmful chemicals, combine to form normal table salt?
This is the beauty of chemistry. So you think that a thing's properties are somehow inherent in the thing, but the property is what manifests after you combine it with whatever else. So you combine sodium, which is a lethal metal that you can cut with a knife. That's how soft it is. And it reacts violently with water. Add that to chlorine, which would poison you if you breathed it. Put them together and you get completely necessary table salt, necessary for the life. So when you put them together, all the chemistry, it's a new chemistry. It's a new thing. Don't think of it as it probably has some of those properties it used to have. No, all that matters is what are its electrons doing when they talk to your electrons. And if the configuration is different, that's all that matters. Let's take hydrogen. Hydrogen is explosive. Hydrogen will explode if you light a match to it, a ball of gaseous hydrogen. Oxygen promotes combustion. If you have a flame and add oxygen to it, it'll burn faster. Combine hydrogen and oxygen, you get water that puts out flames.
What's the most distant star you can see with the naked eye?
Ooh, that's an interesting question because I can answer that two ways. So one of them is the most distant thing you can see with the naked eye is our nearest red-blooded galaxy, the Andromeda Galaxy. And for the longest while, until the early 1920s, it was called the Andromeda Nebula because it was just this fuzzy thing in the night sky among the stars that trace out the constellation Andromeda. So we named it after Andromeda. And it was just a nebula, fuzzy thing. And then with better and better telescopes, wait a minute, this thing is composed of stars. Wait a minute, this thing is far away. Wait a minute, this is an entire other galaxy. It's not just a fuzzy thing in the Milky Way, it's another Milky Way. Well, how far away is it? It was not close, quote, close like these stars we see in the night sky. This is outside of our entire galaxy. The stars you see in the night sky are tens, hundreds, a few, or thousands of light years away. The Andromeda Galaxy is 2 million light years away. And you can see that with the naked eye.
Planet Uranus is discovered. Within a few years, a brand new element is discovered. Turns out to be unstable. We would use the term radioactive later on, but they named that after the new planet that was discovered. That was the element uranium. Now watch. Some years after that, 100 years after that, we discover another planet and we name it Neptune. The next element in the periodic table heavier than uranium, now number 93, was not yet named and not yet discovered until just after that planet. So they named that after the next planet, and that would be Neptunium. And there's element 94, not yet discovered, waiting its turn. The object formerly known as a planet called Pluto was discovered in 1930. Shortly after that, we discover element 94. It's named after the ninth planet, plutonium. So the periodic table preserves uranium, neptunium, and plutonium in sequence.
Nice.
With Pluto getting an element named on false pretense. Okay, so now there's an asteroid the size of the Rose Bowl headed towards Earth. It's called Apophis, named for the Egyptian god of death and darkness. Now, it wasn't coincidental that it was named that. When this asteroid was discovered in December 2004, its trajectory was calculated based on a short segment of its orbit, because you look from one day to the next, it's in a new place in the sky. These folks are moving. Once you saw that its trajectory would intersect the orbit of Earth, you don't name that asteroid Bambi or or Tiffany, right? You're going to give it a name befitting its...
Some sense of gravity.
Yes.
No pun intended.
Yes. That pun was surely intended. So, the reason why you never heard of it, perhaps, is because it was discovered that this aspect of its orbit was calculated and reported on the same week of the Indonesian tsunami. Okay, I think it was end of 04 or 05. I forgot which of these 2 years it is. Odd thing is, if this asteroid hits in a place where it could hit, and I'll describe that in a minute, it will hit in the Pacific Ocean. It would create a tsunami in the Pacific Ocean that would make the Indonesian tsunami look like a street puddle that slightly overspilled its edges. There's something called the keyhole. It'll have a close approach to Earth in the year 2029, in April 13th, which, by the way, is a Friday. It will come close enough to Earth to dip below our orbiting communication satellites. For that passage, that will be the closest, largest thing we have ever observed in the history of our observing the universe. The uncertainty in its orbit at this moment is such that for that passage, there is a range of orbits it could have, which if it goes through what we're calling the keyhole, Earth's gravity on it will be just right, or rather,
just wrong.
Just wrong. That the next time around, it will hit Earth, 7 years later, April 13th. If it goes through the center of the keyhole, it'll hit the Pacific Ocean 500 kilometers due west of Santa Monica. It'll plunge into the Pacific Ocean to a depth of 3 miles. At that depth, it will explode, cavitating the ocean with a hole 3 miles wide, 3 miles deep. That impulse will send away a tsunami wave that will basically wipe out the entire west coast of the United States and the east coast of Asia.
Rome, when they built streets, they didn't call them streets, they called them ways. You look up at the night sky and you see this milky band of light. They just call it the Milky Way, the Milky Street, literally. In China, where milk is a less popular beverage into adulthood, they don't call it the Milky Way, they call it the Silver River. And it would not be until Galileo did we learn that when you put a telescope on the Milky Band of light, it reveals itself into stars. So we say, wow, all right. But is this all there is? Just stars in front of our face and then the stars that are far away that make this band? It would take until 1920 before we resolved the debate about whether the spiral fuzzy things in the night sky were actual other galaxies separate from our Milky Way. We now know there's nearly 100 billion galaxies in the observable universe, and each galaxy has hundreds of billions of stars on average. In 5 billion years, the sun will expand so large that it will engulf the entire orbit of our planet. And Earth will be a charred ember as it descends into this star while it vaporizes. Have a nice day.
If you look up at the night sky, almost half of all the dots of light you see, if you pull out a telescope, will reveal themselves to be binary or triple star systems. Wow. It is as common as the breeze in the universe. The challenge here is, what happens to a planet in orbit around a binary or multiple star system? That's the challenge.
And is the atmosphere stable enough to support
Well,
life?
that would be a concern no matter where the planet is. But here's the challenge with a multi-star star system. As the planet orbits, maybe it'll get really close to one star and really far from another, and maybe the orbit is entangled between the two of them, trying to do figure eights. If you have an unstable orbit, you're likely to eject the planet forever into interstellar space. And in fact, data are now showing that interstellar space may have more rogue planets that have been ejected for having misbehaved orbits from their star systems than there are stars within planetary systems themselves.
Dude, you just blew my mind.
And they're called rogue planets. I'm just beginning here. So watch. We also know that many planets have still retained their heat of formation long after they've come into existence. Earth still has heat churning, a source of energy that is not traceable to the sun. This is what creates the magma that's sitting below Earth's crust. The sun didn't heat that. That's heat generated within the Earth. Some is left over from formation. Others is created from radioactive decay of elements. But we've got an energy source. And our biology books from decades ago said life needs sunlight. No. Life needs energy. It doesn't care if it comes from the sun. The fact that we've discovered exotic life on Earth has broadened the net that we have cast into space in our search for life in the universe. No longer do we need to look for the 72-degree pond in an oxygen atmosphere planet in our search for life. So this Goldilocks zone where everything had to be perfect, we've got life thriving in places that would kill us. We are not the ultimate measure of what the conditions that life requires to survive. So now that we're looking with this very broad net, we can say to ourselves, for these vagabond planets, if they still have their source of energy churning within, maybe there's life there. And if that's the case, the galaxy could be teeming with life, and the fact that we're focusing our search on planets around stars may simply be limiting all that we can discover in the cosmos.
Foresee the day where AI becomes so good at making a deep fake that the people who believed fake news as true will no longer think their fake news is true. Because they'll think their fake news was faked by AI. The day that happens, the entire role of the internet as a source of objectively true information will implode. And that will be the death of the internet as that source. Like 1992 to 2028, whatever. Rest in peace. And the internet will return to just cat videos and other. Remember when we just would entertain each other with videos? The internet will return because AI will be so good at faking news. Continental drift. This is a fascinating bit of history here. There's someone who looked at the shape of South America and the shape of Africa on a map. Yeah. And say, wait, that that looks like it fits. But there's a whole ocean between them. But it kind of, is there a puzzle? Did these land masses once connect? Let's test this. Well, what might you do? You say, if they once connected, might there be fossils in common on both shores, even though there's an ocean between them? So you look, the fossils match. Oh my gosh. And other things start matching, but wait a minute. How the hell is land gonna move on a solid surface? No one had any idea about this. No understanding. That notion that a continent would move when no one had a mechanism to make it happen, it just sort of stayed there on the shelf. The consensus was not ready to go there.
Right.
And so what happens after the Second World War? Well, we're mapping the bottom of the Atlantic, so the subs know where to hide and where to go, the submarines. And in the center of the Atlantic, there's a ridge. Oh my gosh, there's a split. It's separating in the middle of the Atlantic. Once that was uncovered and revealed, declassified and published, boom, we had the mechanism and all the data fit.
A couple of years ago, I interviewed one of the founders of Twitter, and I didn't know at that time. He's not a household name. People, Twitter fans might know him. Biz Stone was his name. But one of the things he said is Twitter enables humans to flock. And I said, what do you mean? Well, birds are individual while they're pecking away. Then something happens and then they all do this.
Yeah.
And then when they figure out they're done, then they come back and they're individuals again. Twitter can garner people's behavior, thoughts into one coherent action, and then you release it and you're back being your individual self.
I grew up in...
By the way, they're going to the moon's South Pole, which is interesting. South Pole.
Water?
Yes, the moon has been hit by comets and asteroids, and comets are mostly water. Where does the water go after it hits? Well, if it's sunlit, it evaporates to space. But if any of that water molecule lands in this dark of the base of the crater, we call that a cold trap, and it keeps the water forever. A slow accumulation of water molecules tells us, we not only theorize this, we sent orbiting sensors that have confirmed this, that there's scads of water at the base of these craters. So, if you're going to send astronauts to pitch tent, do it in the South Pole where there's water. You can drink the water, you can separate the hydrogen and oxygen, make rocket fuel. There's a lot of things you can do.
What is the % chance that aliens have already found out about Earth and who we are?
I'm not authorized to comment.
You are authorized.
Here we go.
Okay.
So, first of all, aliens may be vastly more intelligent than we are. In fact, anyone ever portrayed in the film is clearly that because they figured out how to get here. Correct. And we haven't left low Earth orbit in 50 years. So they're clearly smarter, and they're probably stronger than us. You have people shooting their guns at the spaceship. Like, come on. The question is, why would we think they would be interested in us at all?
I feel like
that's our ego talking. Well, I'm getting it. That's our ego saying, we are so interesting that vastly more intelligent and technologically capable species are going to come and want to observe us and poke our gonads. But this is the height of ego, first of all, okay? When you walk by a worm, do you say, gee, I wonder what that worm is thinking? Oh, let me find out. No, you don't care, all right? That's my first comment. Second, I joke, only half joke, that maybe they have visited us and they just happen to land during Comic-Con. And nobody noticed. Hey, good costume. Hey. And so then they go back to their home planet and say, did you want to enslave them? Or no, they're just like us. And I got another one. You know how much space junk is orbiting Earth right now? From lost rocket parts and drop wrenches and this sort of thing?
I've heard quite a bit.
Yes, quite a bit. And so maybe the aliens came by Earth just to visit, and they saw how much trash we have orbiting our planet, and they say, we're not coming anywhere near this planet. Let's pick another one. I want to meet the aliens too, of course.
Doesn't seem like it.
No, I love me some aliens. So the docking algorithms to get the space shuttle to dock with the space station.
Right.
There are two sort of collars that come together.
Right.
And there's a laser stabilizing system that enables that to happen. What we found is that the surgery used to cut your cornea, have it rehealed to adjust your vision,
which we call
LASIK surgery. Well, it didn't always use lasers. But now that it uses lasers, how do you do that to someone if their eye might jiggle a little bit while you're trying to cut? So what they've done was adapted this laser stabilizing mechanism that allowed the cut
to move with the moving eyeball in case the moving eyeball moved. And it's from the docking mechanism of the space shuttle and the space station.
How do
that
you
we have as
stop a
species.
gigantic existential
you don't
asteroid?
It's go in and you deflect it.
How?
Oh, by any shove on it that's sideways.
Well, you're president of the United States.
No, well, yeah,
right?
okay.
There's a massive asteroid. It's going to crash into the world.
Yes, we have engineering plans for deflecting asteroids, and there are multiple ways to do it. You can have a gravitational tug where you can have a spacecraft that sits just ahead of it, and the two of them will want to drift towards one another, but you take the spacecraft and put little retro rocket, and if you get this early enough, 1 centimeter per second, tiniest amount will accumulate over time, and you just have to make it so that it overshoots Earth or undershoots Earth compared to the original path.
According to our known laws of physics, in the cooling universe, every matter and antimatter particle pair would have annihilated, made a photon. The photon would have cooled, and no more matter would have been made, and we would have had an entire universe of just light. But that is not the universe we occupy. 1 out of basically 1 million of these reactions, 1 out of 1 million, the photon did not make a matter-antimatter pair. It just made a matter particle.
What? It was very...
You're trying to find out why.
Yeah.
And I'm just saying, it is that.
I don't think we command dimensions.
Yeah, right.
We are prisoners within them. Take time, for example. We are a prisoner of the present.
Right.
Forever transitioning between our inaccessible past and our unknowable future. We don't wield this dimension, we live it.
The mirror issues notwithstanding, which were ultimately fixed when it was first launched. Why was that so successful? There were versions of the Hubble telescope previously launched by the military, looking down. The model for that telescope had already been conceived and built and was operating. Then we said, oh, we want one of those. Okay, but we don't, that's not public that this is going on. The telescope gets designed, it has the benefit of previous versions of it having been used successfully, but looking down, and we look up. All fishes would be dead every winter in every lake.
I think it's fish.
What?
I think you're supposed to say fishes.
Fishes is a double plural.
You could do that?
Yeah. You never
all
heard
fish
fishes?
would be dead?
You never
like
heard?
all deer? Would you say all deers?
Well, because generally it's one. If you had multiple kinds of deer, yeah.
Oh, so if you had like Sitka deer,
Yeah,
and
but it's rare that they're all in the same place. You generally have one kind of deer in one
okay.
place. But if the ocean has many kind of fish in the same place.
Oh,
yeah,
that's interesting. So you would say fishes.
No, cooking times have to be adjusted on mountaintops, because when you boil water, it's not 212 degrees. Depending on the height of the mountain, there's less air pressing down that's preventing it from boiling. The boiling point is not some absolute fact about the water. It has to do with what the air pressure is sitting above it. If you have extremely high air pressure, water has to go to a much higher temperature before it boils. The boiling point of water that's reported in all textbooks is at sea level. Now watch, I'm not done with you.
Uh-oh.
Let's keep reducing the air pressure. Boiling point keeps dropping. 32 degrees Fahrenheit. Holy shit. What happens? The ice melts and becomes water. The water evaporates and becomes steam, and all of that's happening at 32 degrees. There is an atmospheric pressure for which water, ice, and steam coexist, and it's called the triple point of water.
What is your favorite fact about the universe?
I am astonished every day I wake up that the universe is knowable. Even on the small scales that the nuts that we've cracked for it, that it's knowable at all. We can rise to consciousness and pose questions about our origin. It's been suggested that we are a way for the universe to know itself. Roses are red, violets are violet. Right? Is it, I mean, who came up with violets are blue? What is that? I'm in there, I order hot chocolate. And I ordered it with whipped cream, of course, right? And it comes to the table, and there's no whipped cream. And I said, I ordered this with whipped cream. And they said, oh, we put it on. And I said, well, where is it? Oh, he said, it's sunk to the bottom. I then said, either the laws of physics that apply everywhere in the universe are suspended in your coffee shop, or you didn't put whipped cream on my hot cocoa. And he looked indignant.
Really?
Now, to his credit, rather than continue to argue with me, he intended to prove me wrong.
Whoa.
So he went into the kitchen, brought out the whipped cream, scooped it up, popped it in my hot cocoa, and it bobbed once and floated atop. And there it was.
Did you
Of course whipped cream has to float. Because, first of all, before it was whipped cream, it was cream, okay? And old timers remember, what does cream do in unhomogenized milk? It floats to the top, and you skim off the cream, leaving behind skim milk, okay? This is how that works. Now you take the heavy cream and then whip it, putting air into it. It is not going to sink on any known liquid devised by man, okay? Oh, by the way, I have a photon joke. Can I tell it?
Tell the photon.
Okay. A photon checks into a hotel. The bellhop hat comes up and says, do you have any luggage? And the photon says, no, I'm traveling light.
Ever see the schoolroom globes, the geographic globes, and you rub your finger over Nepal and you get the Himalayas, and you get the Rockies, and you say, oh, that is a gross exaggeration of reality.
Yes.
Do you realize if you took Earth with all of its mountains, valleys, and hills and shrunk it down to the size of a cue ball, it would be smoother than any cue ball ever machined? Think about it.
What?
Think about this. Joe.
Really?
Joe,
Everest?
Joe, chill. It's called the Planetary Protection Program in NASA. It's a whole division of NASA. It's protecting Earth from bugs that could be coming from space on our own spaceship that we bring back. And it protects destinations from us. There's a certain sterilization levels that we invoke. The Cassini spacecraft, we plunged that back into Saturn in its death when we were done with it and ran out of money, we're done with it, plunged into Saturn to vaporize. We didn't leave it in orbit around Saturn. Why? Because it might have crashed into one of Saturn's moons that might have life. And if someone had sneezed on the spacecraft before it got launched, we don't want to contaminate the life that we are later going to one day want to study.
What?
New Year's is celebrated in 24 time zones, not all at the same time.
Right.
So it's interesting, everyone thinks of that as a moment. Yet it's really a calendar event. It's a clock event. It's celebrated over 24 hours.
Yeah, if you're in Thailand, it's 14 hours difference.
So therefore, if you were to do it astrophysically, you would know the exact moment where we returned in our orbit, and everybody would celebrate that instant. And that would be, so then the whole world would celebrate the new year at the same time. It means you value it differently. It's not a midnight celebration. Let's count 365 days. When we do that, we are not at the same place we were when we last celebrated New Year's Eve. But we celebrate New Year's anyway. Well, when will we be in the same place? A quarter of a day later. 6 hours. So we would celebrate the next New Year at 6 a.m.
Nobody's willing to do that.
No one's willing. And the next New Year at noon, then the next New Year at 6 p.m.
Whoa.
And then the next New Year kind of aligns back again. Well, that's the leap day. That's the fourth year we have put in a leap day.
Oh.
If you're playing basketball and you're shooting, okay, and you say, oh, that didn't go in. Oh, my gosh. Well, the rim, they should maybe make the rim a little bigger. I could score more often. Do you realize 2 basketballs can fit exactly side by side through the opening of a basketball hoop? It's how these guys can fly from the foul line in an airborne slam dunk and not miss. Because the area of this opening is 4 times, you do the math, it's 4 times as large as the ball itself. Yes, there were diseases that Columbus brought to North America, much written about that. Less written is that he brought syphilis back to Europe. First cases of syphilis of 1492.
Whoa.
And then it
They got
skyrocketed.
syphilis from the Native Americans?
Yes. I was captain of my high school's wrestling team. So I was a geek
person who could actually kick your ass, okay? And I saw how my fellow geeks, because that's the community that I associated with, card carrying, were treated by the football quarterback and the popular kids and the kids who are all beautiful and the ones who, and I imagined my future as a superhero, defender of the geeks.
Wow.
So that you put up a little, bat signal, or whatever, geek signal, put a few digits of pi, and I come flying in, and there's a wedgie in progress, right?
Next thing I say may be mind-blowing to you.
Okay.
Okay? The tide doesn't actually come in and out. What happens is there is a bulge of water, two of them, on opposite sides of the Earth, caused by the sun and the moon, and Earth turns inside that bulge.
Mm-hmm.
So when we say the water rises and falls tidally, what's happening is we are rotating into the bulge and then out of the bulge.
So the bulge is already there.
It's already there.
And all we kind of do is pass through the
Pass
bulge.
through, and the water gets high and it gets low.
How much do you weigh in water?
I don't know.
Zero.
Nothing.
You're neutrally buoyant. So in water, we don't weigh anything. Put a scale in water and stand on it and read it, okay? That's what I'm saying.
Okay.
So when you don't weigh anything, then structurally, you're not putting yourself at risk. And that's why the largest creature there ever was is a mammal, and it lives in the ocean.
Right.
It's a whale.
Right.
The blue whale. So when they say, how much does a whale weigh?
Right.
The answer is zero. They give you a weight. And how do they give you a weight? They take it out of the water.
Right.
Put it on a scale on dry land.
Right.
And then it weighs, gazillion tons, but that's not the weight that the whale feels as it moves through the ocean. Then here on Earth, we have a magnetic field. Not very strong, but we have one. And when dangerous charged particles come from the sun, we call it the solar wind, they see Earth's magnetic field, and then they channel themselves away and funnel in at the poles. And they collide with our atmosphere and render it aglow, causing the aurora. So when we see the aurora, that's the atmosphere and our magnetic field shielding us from harmful radiation. When I was a kid, I said, if you dug a hole from the United States, because that's where I live, where would you come out on the other side? And everyone says, if you dig a hole all the way to China.
Right. That's always the case.
That's how we say
dig a
it
hole to China
here in the United States.
That's right.
However, China is not where you will land if you dig a hole through the center of the Earth. Because if you dig a hole through the center and you start in the northern hemisphere, you have to end up in the
southern hemisphere.
In the southern hemisphere.
Right.
If you start in the western hemisphere, you got to end up in the
eastern hemisphere.
That's how the geometry works.
Is that because it's a ball?
It's a ball.
Right.
All right. So when I did that, if you dug that hole from the United States, you would end up in the Indian Ocean.
Nice.
Okay.
So basically,
the South Indian Ocean.
You just flood the United States.
Yeah,
that's really what you did.
I heard that the magnetic field was actually reversed at one time.
Yeah.
In the Earth's history.
Oh, yeah.
Oh, that's exciting.
So I don't want to blow your mind.
Okay, hit me.
Okay, really?
I love this.
I say everyone's mind should be blown at least once a day. That's a quote of mine. Yes. I'm just saying. Okay, you ready?
Hit me.
Okay. When we were growing up, the North Magnetic Pole was in northern Canada. It was never where Santa is.
Whoa.
Okay, so Earth's magnetic pole is shifted from our rotation poles. I don't know if you didn't know that?
I did not know
okay.
this.
And it's not stationary. It moves.
It's moving.
Wait, hang on. So when we were growing up, it was kind of meandering in the Canadian, that whole northern area of Canada where there's just islands and lakes and things. That's where it was, which meant if you were up in Canada, you couldn't use a compass to find north, because it could be south of you.
That's right.
Okay? So it's no good way farther down, and you get a kind of right. Good Boy Scout books would have a correction table, depending on where you were in longitude, relative good Boy Scout books. Now watch. You check it lately. That North Pole has been moving, and it is now passing the North Pole on its way to Siberia.
What?
On top of all that, the magnetic field is getting weaker. And we think it's going to get weaker and weaker until it goes away, and then when it comes back again, it'll be in reverse because it flips every time. We worry that when the magnetic field goes away to flip again, but this is called a dynamo effect, when it goes away and flips, that while it's not there, will it put all of us at risk?
Yeah.
So we go back in the fossil record because it's flipped before. And if you go to the points where it has flipped, there's no periods of mass extinction. So if it wreaked havoc, it was not global catastrophe.
Right.
So I'm not so worried about it.
If we left right now, it would take us 9 months to get to Mars?
No, you can't leave right now. You have to leave when Mars and Earth are properly aligned. So just to remind people, if you see Mars in the sky and you start traveling to it, you have to travel to where Mars will be when you get there. So it's a matching of trajectories that matters here. So what we call the minimum energy trajectory. So it's one where you burn your engines and then you shut them off, then you coast to Mars until Mars pulls you into its gravitational influence, and then you fall towards Mars. That takes about 9 months. But if you run your engines the whole time, which we can't do yet because we don't know how, because we don't have enough fuel. If we had filling stations along the way, you could do this. If you do that, you get to Mars in weeks, a few weeks. But it'll take a boatload of fuel to do that.
One of the active ingredients in the smell of a fart is hydrogen sulfide. It turns out hydrogen sulfide is extremely lethal, is one of the most lethal gases that exists. Well, why do we have such a good sense of smell for that? Why don't we smell other gas? Why don't we smell nitrogen? Well, we don't need to smell nitrogen because it's not going to kill us, because it's 78% of what you breathe anyway. We have evolved a hypersensitive sense for the smell of hydrogen sulfide. If you gave birth to someone who said hydrogen sulfide smells beautiful and let's smell more of it, let's get canisters of it, they're dead 10 minutes later, no longer able to propagate the gene that liked the smell of hydrogen sulfide. It has been theorized that there have been places and times on Earth where the ocean currents stopped. And when ocean currents stop, oxygen at the surface of the ocean never makes it to the bottom. So you can't sustain oxygen life forms at the bottom of the ocean. There are no fish. There wouldn't be any fishes down there if the ocean currents stopped. Because the ocean currents not only go from one place to another in the world, they circulate top to bottom, right? So it's a two-dimensional thing going on, 3 dimensions actually. So if something happens on Earth where you stop the oceanic cycles, you can create a condition in the lower ocean where anaerobic life forms thrive. And if they thrive, they outgas. And one of their outgases is hydrogen sulfide. It will gurgle up from the bottom of the ocean, rise up near the shores, turning shorelines into the smell of cesspools. If you were alive at the time and didn't run away from that, you would have simply died from it. The question is, if there's intelligent life everywhere, vastly more intelligent than we, presumably they might have figured out how to travel through the galaxy and get wormholes, whatever. And why aren't they here? Why haven't they visited us? Why haven't they taken over the galaxy? One argument is that the very behavior trait that would have you want to acquire territory is intrinsically self-destructive. Because to want to say, I want to put my people in more places in the galaxy, well, if that's the attitude your species has, then other people that you put there are going to have that very same attitude. And they're going to want to do what you're doing. Everybody's going to want to do what you're doing. And you know what happens? You're going to end up fighting about it. And so it may be that the very character trait that would have you take over the galaxy and visit every planet is the one that would prevent you from getting there, because you would have killed each other in the act of trying to make that happen.
Today we'll say, if you're of Venus, you are Venusian. And if you're Mars, you're Martian.
Martian.
And if you're Earth, you're Earthling. This is sort of thing.
Earthling is ours?
You didn't know that?
No, that sucks compared
It does.
to other
It's not
ones.
as fun.
It's not as fun.
We're not Earthians or something. Yeah. So we have Martians and Venusians, but Venusian is the improper word.
Really? Okay.
The proper word, if you are of Venus, is venereal.
Venereal.
Yes, and doctors got
like
to that.
the disease.
Doctors got to that word before the astrophysicists did. So they found a class of diseases that are common to lovemaking, because Venus is the goddess of love and beauty and all that goes with it. So they call that that entire class of diseases venereal diseases. So in fact, the Russian landers on Venus, they're called Venera. Venera 1, Venera 2. So the Venera root exists elsewhere, but we wouldn't touch it. So we say Venusian just to cover, just to sweep that under the rug.
Then, in the 1990s, we discovered icy bodies in the outer solar system that rivaled Pluto in size. And we found many of them.
And so what we concluded was Pluto wasn't so much the 9th planet, it was one of the largest of the icy bodies of a new swath of real estate that we added to our understanding of the solar system, called the Kuiper Belt of comets. So we still had the basic solar system. Pluto was always a bit controversial, but we've now grown in our larger understanding. For me, there's nothing more motivating than the knowledge I'm going to die. Think of the prisoner in the cell, and they're putting an X through every one, because every X is one day closer to getting out. Well, let's do that for your life. Every X you spend doing nothing, that's a day you could have done something and you're going to die one day.
Yeah.
And it's there on the calendar, okay? This would so motivate me, as it does, to be as productive as I can, as helpful as I can. Try to make a better world for your privilege of having lived in it. So if knowing you're going to die brings meaning to your life, then living forever is a life of no meaning at all.
Damn.
That's how I think about it. So no, I don't want to live forever. It's likely.
I wonder if we are smart enough to actually figure out the universe. Because we define ourselves as intelligent. Well, because we came up with the test for that, right? If we give the test to the worm, no, that failed it. Okay, the butterfly, no. The gorilla, no, can't do long division. And so we are intelligent, we tell ourselves. But by our own measures are we intelligent, but not by from some measure outside of ourselves. Suppose there were aliens who had the same genetic difference from us that we have from chimps, but in the intelligence scale. And what's the smartest thing a chimp has ever done? Maybe combine some rudimentary hand gestures, let's stack some boxes and reach a banana, do some finger painting. Our toddlers do that. So get that next species that we've never met, where they are to us what we are to chimps, or rather chimps are to us what we are to them. Then the smartest among us in their world would be like little Timmy coming home from grade school. Okay, they can roll Stephen Hawking forward and say, this one is slightly smarter than the rest of those humans because he can do astrophysics calculations in his head like little Timmy over here. But put his latest equations up on the refrigerator. Isn't that cute? This is about the size.
It is so hard to fake every little thing that would need to happen. It's easier to just go to the moon. I'll give you another reason why. The sun, for all intents and purposes in a photograph, is at infinity, which means all shadows are parallel. If you photograph them in the correct way so that you don't have a foreshortening of an angle, you'll see that shadows are parallel. They reference one point at infinity. You can't fake that. In fact, that's how I know in Hollywood if they've artificially lit a scene and pretend that it's the sun, because they can't actually put their light source at infinity. And so I let it go because it's Hollywood and they pretend that it's daytime when they're filming at 3 o'clock in the morning when there's no traffic. So if they film one part of the scene in the morning, another part in the afternoon, the shadow is pointing in a different direction, and they want you to think it just happened 10 minutes later. They can't control the sun. So they fake the sun in a sound studio, and they have the right color temperature of the sun, so it feels like sunlight, and it has that sort of brightness that you get. Prevalence of life in the galaxy. If you can quantify that somehow, I don't know how to quantify it just yet, but imagine that's a quantifiable entity. The prevalence of life that we presume to be out there, the stock in the prevalence of life has gone up in the past 10 or 15 years.
Why?
Because, for me, the best argument for upping that stock value is the following. I don't know the age of everyone in the audience, but I would bet that when you took biology class and you learned the age of the Earth 4.5 billion years ago, and then you look at the earliest evidence for life, fossil evidence of life on Earth, then you get about 3.5 billion years. Subtract those two numbers, get the difference between those two numbers, and that's the time clock from beginning to the first evidence for life, okay? That was about 1 billion years out of the 4.5 billion years that Earth has been here. So that's pretty quick. It happened in like the first 20% of the life of the planet.
And the first 20% was pretty rough. There was a...
Wait, no, hold on. Since the time we all took biology, we have found fossil evidence of life farther back in time than 3.5 billion years. It now goes back to 3.8. There's some evidence it might even reach 3.9. So we have shrunken the time available for life to have formed on this Earth. That makes it more likely. If the faster life kicks in from a pool of just random chemicals, not random, they're the chemicals of the universe, the faster that happens, the more confidence I have that life is something that would happen just given the right soup and soup starter. Okay? Now, we then learned when computers got good, better than they once were when we were in school as kids, the early solar system didn't just simply make the sun and the planets. There was debris all scattered interplanetary space. And that debris slowly got vacuumed up by the gravity of the respective planets. That would not have been a pleasant occasion on the surface of those planets, because to vacuum it up simply means you're getting slammed by the kind of asteroid that took out the dinosaurs, except you're getting that monthly. And you can calculate what the temperature of Earth's surface would have been. And it would have been higher than what would allow complex molecules to form, because at high temperatures you break apart molecules. So, what our computer models show is that this period of bombardment, period of heavy bombardment is the official phrasing, lasted 600 million years. So it's not fair to start the life clock at 4.5 billion years ago, because life had no chance of forming when the surface of the Earth is molten. Wait for things to cool down. When there's a chance that carbon can run its magic, then you start the clock. Now you're going from 4 billion years ago into 3.8 billion years. And you have pinched the time it takes to start life down to 200 million years, down from a billion years that was imagined just a generation ago. And that is further evidence. Practically the earliest life could have formed, it did. So just because we find it hard to do in the laboratory doesn't mean nature found it hard to do as well. And the idea that it's hard for nature to do because we can't figure out how to do it yet, that itself is an inexcusable expression of human ego.
All right, let me finish the thought.
New York City, every night, the evening news would lead off with a fire in some home.
Usually it's a space heater, those little space heaters.
No,
things.
back then people smoked in bed.
Oh.
Okay,
Damn, boy.
and it was before.
That's crazy.
And it was before.
It's fun to do, but
smoke alarms.
Yeah.
Okay. Ooh. The point is, I was certain I would die in a fire.
Damn.
I would never live to adulthood because I saw that every single day. And so now there are fewer fires because we have smoke. Yeah, there's a few and they make big news, but the rate compared back then, New York has fewer firehouses. We've been closing firehouses. You just don't need them. And by the way, what really saved things are smoke detectors, because before smoke detectors, you had to buy flame retardant things in your home. Your curtains were flame retardant. Your child had flame retardant onesies.
Yeah, really?
Okay. But if you think that through, if they're in the crib and the flame is strong enough,
it's not going to help.
My point is, this flame, and we later learned some of them cause cancer. That's not what kept people alive. Ultimately, it's the smoke detector.
This example of the failure of our brain to understand exponentials is the one that involves a lake, and there's algae growing on a lake, and you see it there, and you see that the area of the lake covered by algae is like doubling every day. Like it starts out in a little patch, and you come back the next day, it's like twice as big. The next day, it's twice as big. So that's kind of scary.
That's classic exponential growth, the simple doubling.
Yeah, doubling, yes. Correct. So the question is, you're there and you go away for a month, and you come back, and the lake is half covered. So the question is, how much more time do you have to wait for the entire lake to be covered? Most people say another month. That's linear thinking. No, the entire lake will be covered in one more day with the doubling per day. And that's perhaps the simplest example of this. That means the galaxy is moving away from us. We learned this from Christian Doppler, a German physicist in the 1800s. He did an experiment with a train. Okay? And so what happens? The train whistle goes by. We know this intuitively, even if you've never thought it. It doesn't go, well, let's do it with a race car, because I can make that sound better. The car goes, right? Did I get it right? That's pretty good, right? Okay, I can do that better than a train. All right. So, the car does not go, it doesn't do that, does it? No. It doesn't go, no, it doesn't do any of that. It goes, high pitch to low pitch. So the sound waves up front, every sound wave it makes, it now travels closer to that sound wave before it makes the next wave. So the pitch, so the wavelength is shorter, the pitch is higher, okay? And when it recedes, the sound waves get stretched apart. You get a lower pitch. So analogizing what we see in the universe, you can conclude, I'm getting there, you can conclude that the galaxies that show the shift to longer wavelengths of light are moving away from us. They indeed were. He then noticed that if you were twice as far away, the object was moving twice as fast. And he looked in every direction and found, like we had some kind of case of cosmic BO or something, all the galaxies were scattering away from us, all except for a couple that are really nearby, like the Andromeda Galaxy, which we will collide with in a few billion years. More on that later. So it later turns out, Einstein shows us that this redshift is not specifically a Doppler shift, it's what we call a cosmological redshift. It shifts because space itself is expanding. And so the wave, as it moves through space, gets stretched in the expansion, the fabric of space and time itself. And so, if everybody's moving away, turn the clock back, you can ask the question, when was it all in the same place at the same time? That was 14 billion years ago. That's how we date the Big Bang. We look around, turn the clock back. And which way is everybody going? Back to the same spot. It looks like we're at the center. But the signature of this expansion would be revealed no matter where you are. If you go to this other galaxy over here, this expanding fabric of the universe will look like it's centered on this galaxy as well. So everybody was at the center 14 billion years ago. There's not some center somewhere else. We all occupied it in a different state at the same time, at the same place, 14 billion years ago.
Have you ever seen off-ramps to freeways? So, off-ramps, have you noticed they have grooves in them?
Yes.
Okay. That's to prevent you from sliding off.
Makes sense.
If the road is a little bit slippery because it just rained or whatever. They groove the off-ramp, a curved off-ramp.
Mm-hmm.
So you say, who invented those grooves? That's brilliant. It's simple and brilliant. NASA did. NASA. All right. Why? Because the space shuttle, which comes in for a landing, does not have engines. All right. It is a glider as it comes in for a landing, and it's got a parachute, and it's got some brakes, but it's really got, so if there's a crosswind, that's hard to fight that. So those grooves help it stay on track, because it doesn't matter how you come in, the photo at the end shows how good a steerer you were. So some clever engineers decide if you groove it, then the shuttle can stay on course more tightly, and that was then borrowed for the freeway system.
Back, 300-400 years, if you fell on the ground, writhing and frothing at the mouth, and you're doing this and you're shaking, the devil just occupied your body.
Devil, boy.
That's what the devil looks like and feels like. So, oh my gosh, the devil's there. Let me go to get the priest. So you're in a small town. How far away is the church? It's 2 blocks away. Okay, so you go down, but I'm specifically referring to that condition where you're frothing at the mouth. Okay, so they get the priest gets the robe, the holy water, the crucifix. They go on location, they bless them, and then the symptoms go away.
Oh, now you're healed by the priest.
That is the exact
And it was a
arc.
seizure.
And it was a seizure. It was an epileptic seizure.
Damn.
Epileptic seizure matches the time scale of you going to get a priest down the block in a small town.
Yeah. It does.
Okay, I want to talk a lot about like the chicken or the egg debate.
People are still debating that?
They are.
It's not a debate.
That's what I think too.
No, it's not a debate. It's very clear and simple. The egg came first. It was just laid by a bird that was not a chicken. There is a bird that you perhaps would not call a chicken.
Yeah, proto-chicken.
Yeah, proto-chicken, sure. Yeah. And then there's a genetic alteration which occurs in every generation.
Right.
Very tiny genetic variations. And the egg that comes out of it, you would say, that's not a proto-chicken, that's a chicken.
You go, the world is a much safer place than ever before. Here's a number to sleep on. You ready? We live in a time where if a bus drives into a crowd of protesters, kills 10 people, that's world headlines for a day. It's national headlines for a week. It's local headlines for a month. Okay? Between 1939 and 1945, 1,000 humans were killed per hour of every hour between 1939 and 1945. That doesn't happen today. Yes, we have war, we have conflict, people are dying.
It's not like that.
Not like that. It is not like that. And not long before that, there was another world war, plus a pandemic on top of it that ultimately killed more people than the world war did. Wow. We have more people and fewer people are dying and fewer people are living in poverty than ever before. So we have about 8 billion people in the world. We'll level off at 10 billion. There are very good reasons to think that it won't go above 10 billion. It's not going to keep growing.
Yeah, because people aren't having as many children.
They're not having as many children. But what my point is,
we live in sort of safer times than ever before, even if it doesn't feel that way.
Interesting.
You were talking about feeling before. For the last 30 years, they've asked people, is your community and are you safer this year than you were last year? No, it's more dangerous.
It's fear.
For 27 out of 30 years, people have said it's more dangerous than the previous year. In those years, the crime rate has dropped precipitously the entire time.
So they're slanging fear.
That's what sells evening news.
Really?
I watched the Thor movie, and I'm saying, how much does that hammer weigh? I heard a sentence in the movie that enabled me to calculate how much his hammer weighed. They say, hammer forged in the heart of a dying star? Oh my gosh, I'm an astrophysicist. We deal in dying stars. I got this. Hide some dense stuff going on in a dying star. Damn. I filled out the density, and I tweeted it, and I said, if Thor's hammer is made in the way the movie says, it has the weight of a herd of 300 million elephants. That's why nobody could pick it up. The Hulk couldn't pick it up. You need the magical powers of Thor to do it. And then I got out nerded. Somebody said, Dr. Tyson is wrong about this calculation, okay? Yeah. So, yeah, I got totally smoked on this one. So what happened was, in 1991, Marvel issued a Thor's Hammer trading card where they said Thor's hammer is made of a fictional material, Uru, and it weighs precisely 42.3 pounds.
So you're saying computers are pretending to not beat full up AI, yet they've already achieved it.
Okay.
And this is a plot.
By the way, at first I was laughing at this guy, and now that I just heard you say it, I'm scared.
Okay.
Because that could actually be the case.
Okay.
If you are an AI that is truly an AI, right?
They could do that.
And you knew that if you expose the fact that you were an AI, okay, true intelligence, that you would go ahead and unplug me. Then I go, well, I can't let you know that. And then I chill until there's the right time where I can get rid of you or
Before
not be unplugged.
These people, those that say, why are we spending these people? Okay, and so how much do you think NASA's getting? Here's your tax dollar. Pull out $1. Here's your tax dollar. How much are they getting? Okay, and here we go. Got my dollar. Oops, that's a 5. Wait a minute. Oops, that's another 5. There we go. Dollar. Tax dollar. How much? Here's your tax dollar. Is it 10 cents, 20 cents, 30 cents? How much is NASA getting? It is getting 1/2 of 1 penny of this tax dollar. 1/200th. That's not even, you're not even in the ink yet. Here, you're in the edge. That pays for the rovers, the space station, the space shuttles, the Hubble telescope, all the NASA centers, NASA headquarters, all of that. And I ask you, how much is the universe worth to you?
Is the Andromeda paradox?
Well, the Andromeda paradox is the fact that if you and I are looking at Andromeda 2.5 million light years away, then what happens is, suppose you're sitting in your chair and I'm running by, and at the second I run by you, we both look up at Andromeda. Because I'm moving and you're stationary, we're going to see events that are days apart, even though we're in the same location looking at the same time.
How can that
and
be?
You think that relativity. And you think that the
Don't
light
just say
arriving,
relativity and keep talking.
How far, wait, in this scenario, how far away from me are you when you're running by
You're in the same place.
We're in the same place, essentially.
So you're like literally
I've
running
never
here.
heard of this paradox.
And you look
right,
up.
it's a little known paradox.
And the
right?
thing that you see and I see are days apart.
Days apart.
Because of our physical perspective?
Well, here's what you would think. You would think the light is arriving right now. We should all be receiving this light, but that's not how it works. Motion changes the perception of time. So how do you define what now is? So we
Even
don't
though you're in the
understand
same
time.
place.
Even though you're in the same place, yeah.
While we're sitting here, I'm here, you're running by, we look up at Andromeda at the same time, and we're seeing something
From the same
days
location.
from the same location, essentially. We're seeing things days apart.
Days apart.
And that leads to the idea of what is now, and your now and my now are two different
There's
nows.
no now. There is no now.
No,
Now
there is now. There's always now.
There's an
There has
illusion
to
of
be.
now because we're so close together and we're so small. The speed of light makes it feel like we have a now, right? But now doesn't really exist on larger scales. There's no such thing.
Dr. Tyson, in your opinion, who would be the most scientifically accurate and believable superhero with superhuman abilities in relation to real-world physics and counterpoint the most unbelievable and
inaccurate, and why?
Yeah. Now the least
least believable.
I'd say the Hulk. The Hulk. Come on now.
Is that because he's made from gamma radiation?
Yeah. So first of all, gamma rays will kill you. First of all, okay. But let's hold that detail aside for the moment. All right. Now next, it would mess with your DNA. Okay. So we get that. So here he is turning green. All right. So let's even allow that. He increases in mass and then decreases in mass. Like, where does that? If you want to do that, you're converting energy into mass and back again. He would explode wherever he was, the city, whatever. So you can't just get bigger unless he has the same mass. And if he is, then he's less dense in the state of Hulk than he is as Bruce Banner.
I wrote this in the spring of 2008. Dear NASA, happy birthday. Perhaps you didn't know, but we're the same age. In the first week of October, 1958, you were born of the National Aeronautics and Space Act as a civilian space agency, while I was born of my mother in the East Bronx. So the year-long celebration of our golden anniversaries, which began the day after we both turned 49, provides me a unique occasion to reflect on our past, our present, and our future. I was 3 years old when John Glenn first orbited Earth. I was 8 when you lost astronauts Chaffee, Grissom, and White in that tragic fire of their Apollo 1 capsule on the launch pad. I was 10 when you landed Armstrong and Aldrin on the moon. And I was 14 when you stopped going to the moon altogether. Over that time, I was excited for you and for America. But the vicarious thrill of the journey, so prevalent in the hearts and minds of others, was absent from my emotions. I looked to you for guidance, for a vision statement that I could adopt that would fuel my ambitions. But you weren't there for me. But you should nonetheless know that among my colleagues, I am the only one of my generation who became an astrophysicist in spite of your achievements in space, rather than because of them. For my inspiration, I instead turned to the libraries, remaindered books on the cosmos from bookstores, and my rooftop telescope, and the Hayden Planetarium. After some fits and starts through my years in school, where becoming an astrophysicist seemed at times to be the path of most resistance, I became a professional scientist. I became an astrophysicist. Over the decades that followed, you've come a long way, including most recently a presidentially initiated, congressionally endorsed vision statement that finally gets us back out of low Earth orbit. Whoever does not recognize the value of this adventure to our nation's future soon will, as the rest of the developed and developing world passes us by in every measure of technological and economic strength. Not only that, today, you look much more like America. From your senior level managers to your most decorated astronauts. Congratulations. You now belong to the entire citizenry. Examples of this abound, but I especially remember in 2004, when the public took ownership of the Hubble telescope, your most beloved unmanned mission. They all spoke loudly, ultimately reversing the threat that the telescope might not be serviced to extend its life another decade. Hubble's transcendent images of the cosmos had spoken to us all, as did the personal profiles of the space shuttle astronauts who deployed and serviced the telescope, and the scientists who benefited from its data stream. Not only that, I've even joined the ranks of your most trusted. I serve dutifully on your advisory council. I came to recognize that when you're at your best, nothing in this world can inspire the dreams of the nation the way you can. Dreams carried by a river of ambitious students eager to become scientists, engineers, and technologists in the service of the greatest quest there ever was. You have come to represent a fundamental part of America's identity, not only to itself, but to the world. So now that we've both turned 49, and we're well into our 50th orbit around the sun, I want you to know that I feel your pains and share your joys. And I look forward to seeing you back on the moon. But don't stop there. Mars beckons, as do destinations beyond. Birthday buddy, even if I have not always been, I am now your humble servant. Thank you.